I hope we are live. Boys and girls, we are live. Oh yeah, we are live. Hello people, welcome to your own Unacademy NEET English channel. Just tell me, can you hear me properly? Of course you can see me because I can see myself on a number of devices. Thank you, Sausi. Can you hear me? Confirm? Confirm. Yes, Naisha, thank you so much. You're a darling. Well, all of you, once again, confirm in the chat box. I want the chat box to be very, very full with just one message for me that you can hear me and see me properly. Yes, the mic is on, the camera is on, ma'am is always on. Yes. Good evening, good evening. After a hiatus, after a while, this chapter, loveliest chapter of the syllabus, but the most feared chapter, photosynthesis in flowering plants. Now, ladies and gentlemen, get into the classroom pretty quickly because this chapter, perhaps this year, has one of the highest weightage in class 11th biology. And we are going to make it super easy. Today, I'm going to tell you the good and the bad parts of this chapter. Although there are no bad parts, but you know how your mind thinks. For a while I'm going to think like that. So I can see some hearts. I would really appreciate more hearts in the chat box. It's fuel to my fire. Yes, it's a beautiful evening out here. Yeah, let's make learning fun and fall in love with botany like we always do. It's an auspicious day otherwise for this country, and it's definitely an auspicious day every day for a NEET aspirant. Photosynthesis in higher plants, share the session with as many people as you can because I'm going to do it differently. Okay, we are going to solve PYQs, and because I have been a student myself and faced problem in decoding this chapter, which is not like the usual biology chapters that we see every day, isn't it? Mayuk, thank you so much. Varshini, darling, I intend to keep it as short as I can because this chapter has a lot of technicalities. The good part is, I'll tell you the good part later. Wait, let me see who all are there. Ramesh Kumar, thank you so much, Ramesh. You are a darling. You are my dearest. Good evening, good evening. From auspiciousness, what I can remember, we start a new batch today. Yes, how many of you have joined this fabulous batch? The NEET Endgame 2.0 batch has also started today. Yes, fire in the chat box from Endgame 1 people as well. The original batch that started on 2nd of January. Not that this is a duplicate batch. It is just another chance for all NEET aspirants to study from this fabulous team. Yeah, so we launched this batch today. If you haven't joined, the link is given in the description box. Join it right now. Use the code PM1Live to get this discounted. Price. It's the least price for this batch that has been introduced. Yeah. Endgame original people can really write in the chat box how amazing Endgame 1 is going on and how much they love studying from these fabulous teachers. You have me for botany. You're going to taste the botany like never before flavor in today's class. You have Ambika ma'am for zoology. You have your very own Wasim sir for chemistry. You have HSP sir. You lovingly call him Baba, right? You have Kailash sir and Yavar sir to make a subject like physics super easy. Yeah, you have the experience. It's not like you just have to believe the words. You have experienced it all with this wonderful theme. Yeah, you should be in fact grateful. All right, ladies and gentlemen, let's start the chapter on this evening, shall we? Yeah. Be very careful of what you do in the chat box because I'm in a mood to switch off the chat box altogether if you guys create a lot of fuss. Let's begin the session. Alright, let me tell you the weightage of this chapter here. Yeah, weightage of this chapter. So boys and girls, like I was saying, till now, photosynthesis in higher plants has garnered a weightage of 4 questions, which is around 20 marks in NEET paper. This was up until 2023. With me? In 2024, boys and girls, remember, we don't have transport and plants and mineral nutrition. Together, yes, as the syllabus reduces, on the surface it looks like a good news, but you have to remember that the weightage and quality of every single chapter increases. Yeah, every single chapter gets more weight because the number of questions are still the same. So now this year, mark my words, you are going to get at least 5 MCQs. They're not going to cross 5 MCQs per chapter. So did I say 20 earlier? Yeah, my mathematics is awesome. It's a different mathematics altogether. My mathematics books and calculations are different. So it's 20 marks. Yeah, this year you're going to get 20 marks. Nevertheless, the level of questions is going to be moderate to difficult in 2024. I'm not trying to scare you. I'm just telling you that you guys need to get serious with this chapter. Okay? Now, the good part of the chapter. This was a little, oh ma'am, we have to be serious. We never want to be serious in life. Yeah, the good part of the chapter is, in other chapters of biology, as biology is accused of a lot of concepts to learn, lot of examples, a lot of hormone functions that we did in PGR, although we had tricks for everything. This chapter is entirely technical, and with that comes the advantage of better retention. What did I just say? Can you type in the chat box, please? Yeah, because this is the special part of this chapter, that retention is super awesome. Now, those of you who have a little bit of base to this chapter, okay, and are watching this one short lecture, I am expecting that you have a certain basic foundation of this chapter. Quickly give me the answer of this question that was asked not long ago, but just not even 12 months back. Yeah, time has this property of running very fast. 2023, ladies and gentlemen. Yeah, I am not framing a question of AIPMT 2009, 10. Come on, while I have the sip of my special coffee. Awesome, awesome, good. The question will come from these concepts that I am going to solve with you. The entire session is going to be filled with PYQs. Okay. So the question is, Rubisco is the most abundant enzyme in the world. Yes, ma'am. We have heard that. Okay. Even if you know this chapter up to 95%, you are going to learn photosynthesis like never before. I am claiming that. Okay. And if you are absolutely new to this chapter, you don't know a thing about it, then you should study with me photosynthesis word by word, because I am not going to do NCERT decoding here. NCERT of photosynthesis is the most encrypted form of any chapter. Yeah. So we will do it in endgame batch. Cool. You should study each and every word in endgame batch. This chapter is not going to make sense if your basics are not clear. As simple as that. Photorespiration does not occur in C4 plants. Yes, ma'am. That is why they are so popular and special. Both the statements are correct. Both the statements are correct. Okay. What are we going to do today? What are we going to do today? First of all, we are going to introduce ourselves to this process, because this is one of the most important, no, not one of the most important, this is the most important process that is keeping all of us alive. You and I and the entire animal kingdom. Then we are going to go into the early experiments. In other chapters, we don't really care about the early experiments. But in this chapter, they are very important, because the discovery of photosynthesis, as my mother tells me, is still happening. There are experiments still conducted, because it is such a multi-step process, such a complex process. It's not like, hey, Monday morning, I want to do photosynthesis, ha ha, get up in the morning, dress up and photosynthesis. It's a very, very conditioned Okay, very, very sensitive process. Little bit here and there happens with carbon dioxide concentration in the atmosphere of the plant. Little bit here and there happens in the water content in the soil. Little bit happens here and there with the mineral content in the soil. The process goes out of the window, goes for a 6. The plant struggles. Okay, so it's a multi-step process. What all experiments led to the discovery of photosynthesis as we know it today? We'll study that. Very important for MCQ. Then the site of photosynthesis, which is nothing. Can you answer in the chat box? What is the site of photosynthesis, boys and girls? It is the chloroplast. Now in the chapter of cell, you study the structure of chloroplast. We'll study it again today. Ma'am, it's never enough. Yeah. Then we'll talk about the pigments. When we talk about the pigments, you know it's chlorophyll pigment. We will talk about the action spectrum and absorption spectrum, which you guys make humor out of. Yeah, the way people study the spectra is quite amusing to me. Photosystems, that is the arrangement of pigment in the chloroplast. We will study about PS1 and PS2. Yep, you'll have to be patient today. And the class, people who are asking about the duration of the class, it's going to be a 4-hour class. Yeah, it's not going to be a long class, I promise you. It's a 4-hour class. I'm just smiling for another reason. I'm not lying. It's going to be a 4-hour class. Yeah. Then comes the light reaction or the Hill's reaction. I absolutely love this chapter. I tell you very honestly, my feelings, I hate it. No, I didn't hate, but this chapter scared me a lot when I was in class 11th. And I started loving it when I became a teacher. You'll see why. Kelvin cycle or the dark reaction, ladies and gentlemen. Dark reaction, photorespiration, which is the evil process, and C4 cycle or the HSK pathway. Blackman's law, Blackman. I really like Blackman. And factors affecting photosynthesis will be the last part, which is the 4th hour of the session. Yes, I am pretty sure everybody is in line. Yes, show me some fire in the chat box. Come on, people. You guys are so lazy. Why are you so lazy and stingy on liking the session, loving your teachers? Yeah, after 10 days I get a message somewhere, ma'am, I did not understand this topic. Can I now join endgame batch? Guys, when 1 month is remaining in the exam, you can't ask your teachers, can I still clear the exam? Be practical about it. Yeah, and share the session. Nobody is going to do anything to you if you share this session. They're just going to thank you. Very good, very good. People are topping only in botany. It's called botany tropism. Let's go further, people. Let's go further. Oh, there's another question. Can you solve this question? This is also from NEET 2023, just giving you an idea what kind of questions are asked from this chapter. Come on, people, like never before. Which out of the following statements is incorrect? Now, I'm telling you, 2024 is going to be a multi-statement question paper, just like 2022. So, be prepared for it. Pull up your socks, don't regret later. And there'll be a lot of questions asking what is true, what is false, what is correct, what is incorrect. Are we together? So, grana lamellae have both PS1 and PS2. Since I always say, all your teachers say that Game of NEET series is if you already have a base of the chapter, this is just revision, you should be able to solve this. Grana lamellae have both PS1 and PS2, this is correct in our world. Cyclic photophosphorylation, ooh, that's such a big word, ma'am, I'm super scared. Involved both PS1 and PS2, this is incorrect because cyclic process involves only PS1. Both ATP and NADPH2 are synthesized during non-cyclic. Yes, ma'am, this is true. Ma'am, I have no clue. If somebody doesn't have a clue of what all it is, be very honest with me. You are going to be my favorite student, write it in the chat box. I have no clue. It takes courage. It gives you a superpower when you say words like, I don't know, I am sorry, and thank you. Try it out. Stroma lamellae lack PS2 and NADP reductase. Oh yes. Okay, so we got our incorrect statement. Now, what is photosynthesis, boys and girls? What do you think? If I break this term, photo is light and synthesis is formation. So something is happening in the presence of light. Okay, it is happening in a living cell. In a living cell, if I am forming something, okay, metabolically, I give it a fancy term called as anabolism. Yeah, metabolism is of two types in a cell. Metabolism is a defining feature of a cell. Either it is catabolic or it is anabolic. This is synthesis of something in the presence of light. Plants only have the superpower of interacting with such a strong, the strongest form of energy, the physical form of energy, that is Lord Suryadev, yeah, Lord Sun, interacting with these photons of light. You and I or any member in the animal kingdom cannot do it. They convert this energy into a form that we can utilize. Okay, we can utilize energy. Universal energy currency is ATP. However fancy the food is, however tasty the food is, that is just for sensory pleasure. Ultimately, my cells need ATP. Okay, so plants are doing that. Plants are green in color. If I am interacting with light, with photons of light, I need to have, I mean, if we go out and stand in the sun for like, try it out for 20 minutes, 25 minutes, the skin is going to start burning. We are buying sunscreens like never before. Okay, so plants need to have that pigment. If I gather all this information, then I don't need a book to give me the definition. I can frame it on my own. Give me a moment. Yeah. All right. So it is a anabolic. If it is an anabolic biochemical reaction, it would need enzymes. That is not news to me. Anabolic, enzyme regulated. Can I write biochemical? Would you allow that? Biochemical? Yes, because I am going to interact with a lot of chemical bonds. Anabolic, enzyme regulated formation. I am making carbon rich compounds. Yes, formation of organic materials from carbon dioxide from simpler molecules. That's the definition of anabolism. Carbon dioxide, water, okay, in green parts of the plant. You know what? By green parts of the plant. By green parts of the plant. Can I write, since we are a little grown up, yeah, can I write chlorophyll containing? Yes, ma'am. So even if a young stem contains chlorophyll, a baby stem contains chlorophyll, she will not shy away from performing photosynthesis. And by green parts of the plant, in presence of sunlight, thereby liberating oxygen. Now, for plants, oxygen was just a byproduct of this reaction. Plants were like, we want to make food. Oh. Plants were not aware that they are actually going to make food for the entire planet. If you have studied ecology with me, I always say this line, yeah, if you want to kickstart the engine of an ecosystem, You need photosynthesis, you need producers or plants, and that is why, ladies and gentlemen, plants are called as transducers, because they are the only ones, I can't say this enough, who convert the physical form of light, photons of light, into chemical form of energy. An ecosystem will not see the entry or sight of any heterotrophic animal, okay, till producers have done photosynthesis. So this is the only process that leads to autotrophic nutrition, which is the basis of any ecosystem. If you have not studied ecology with me as of now, we are going to do it in endgame batch. People are asking questions, ma'am, 11th and 12th syllabus both will happen. Why do you think only 11th or only 12th will happen? Why do you always believe in the otherwise? Yeah, this world runs on faith here. We'll do every word of ecology in endgame batch from the scratch. This is the only process where I see, although it's a byproduct, but this is the process which gives us the energy, the life force. We cannot live without oxygen. Try getting stuck in a lift for a minute, you would realize. Yeah, so this is the only process that removes carbon dioxide, which could kill us, and generates oxygen. Okay, and it produces the biomass for the planet. 170 billion tons. This is a question from ecology. I'm just connecting two chapters. 170 billion tons of biomass is produced every year on the planet owing to photosynthesis. 1 billion tons of biomass per year. And the amount of carbon dioxide that I'm fixing, if I'm not wrong, this data has to be learnt. Yeah. If you were thinking life is easy, 70 to 80 billion tons. 70 to 80 billion tons of carbon dioxide is fixed every year by terrestrial plants. Terrestrial plants account for 68% of the photosynthesis. Why am I telling you all this? Because this is not mentioned in chapter of photosynthesis, but I am connecting ecology and photosynthesis. Now we are going to go to the mechanics of it. Pretty interesting. We are going to take a twist, take an interesting turn in our story. I know textbook and usually we do the early experiments. Yeah, this is the sequence, but I'm going to change the sequence. Yeah, we are directly going to go to the mechanics of photosynthesis, and you will see the magic happening. I'm going to do early experiments also, each and every word, in the second half of the evening. So you got to stay for long. Mechanics of photosynthesis. Now, like I said, this is quite a dense and multi-step process. And from childhood, we are going to write the basic equation. We are not going to write the balanced equation, the true equation as of now, till we don't evidently see it, till we don't arrive at it. So we are just going to write from the definition that carbon dioxide is combining with water in the presence of light, chlorophyll, it has enzymes, okay, and it is giving me C6H12O6 plus oxygen. With me? Oxygen. Okay. Little bit, if you want to go a notch further, 6 and 6 molecules each. I know this equation is incorrect, but once you understand the mechanics, we'll deal with the real equation. This whole process, as simple as it looks, is not happening in one step. It happens in a light reaction. Because it is quite a task. Like I said, even if we want to go for 5 minutes out in the sun, we want to apply the sunscreen. I've never understood the concept of sunscreens though. These guys have to interact directly with that intense light, the sunlight, the electromagnetic spectrum, powerful radiations. Yes, so that happens in light reaction. also called as the photochemical phase. Photochemical phase. Why did I call it photochemical phase? Because photons of light are going to be converted into the chemical energy. With me? The second phase is the real business. I got chemical energy. My cell is filled with chemical energy. Now comes the time of making the food, the anabolism. And I am going to now reduce carbon dioxide into glucose. So that is called as the dark reaction. Dark reaction, or we can say biosynthetic phase. Biosynthetic phase. Do you all agree? Now we are going to study about the light reaction. Okay. So light reaction, what will it give you? Where will it happen? What is the aim of this chemical reaction and where is it happening? Well, light reaction, the site of light reaction is the chloroplast. Sorry, is the thylakoid. Is the thylakoid. Yes. And the site of dark reaction is the stroma of chloroplast. This much we know, ma'am. Other than that, we do not know anything. It is okay not to know anything. Are you guys with me? Fire in the chat box like never before. Yeah. So now we are going to start with the first one, that is light reaction. Light reaction. Are you all ready? Have you given the heading? In order to understand light reaction, number one, I study what is a chloroplast. What is a chloroplast? Because that is the site. Then I study the pigments of photosynthesis. Pigments of photosynthesis. Okay. How is oxygen? Oxygen, how is it liberated in light reaction? Then I understand that there is formation of ATP and NADPH in light reaction. Yes. So I understand this. In this, when I study the pigments of photosynthesis, I will study about the action and the absorption spectra. When I study the oxygen evolution, I will study the oxygen evolving complex. Oxygen evolving complex. And then when I study the mechanics of light reaction, I will study how ATP and NADPH are produced. Is everybody clear? So first of all, what is a chloroplast? Let's draw a chloroplast together. Everybody, let's draw a chloroplast together. For that, you have done this in tell me quickly in the chat box, is it a single membrane or a double membrane organelle? I am making stroma bluish in color. Okay. This is not the membrane part, this is the stroma part. It's a discoid organelle. If you talk about algae, the lower plants, we will see various shapes. Here I am in Spirogyra, I am spiral. I am in Zygnema, I am star shaped. Yeah, I am cup shaped. But as you go to higher plants, we see a simple shape of chloroplast. What is that simple shape that plants have taken up? That is your discoid shape. So it's a, like you rightly said, it's a double membrane enveloped structure. Discoid. Tell me what is present in the outer membrane. Starts with P. P is of botany. What is the structure present in the outer membrane, also seen in nuclear envelope? Quickly means quickly. I want answers like there is no tomorrow. Come on, ladies and gentlemen, you guys have been lazy. Now we are going to mark the parts here. This is the outer membrane. outer membrane, everybody. This is the inner membrane, everybody. What is the membranous space known as? In any double membrane envelope structure, you will see the intermembrane space that will protect the organelle from collapsing. Yeah. In fact, my English is also, it is called periplastidial space. Periplastidial space. This is revision. This is not a part of this chapter. I am just being nice enough to repeat it for you. Guys, it is called as periplastidial space because chloroplast is a type of plastid, na baba? Plastids are of 3 types: chloroplast, chromoplast, leucoplast. Chloroplasts are most abundant because of the presence of photosynthesis. Yes or no? I assure you, you did not study this in last birth. It happened in this birth. Please remember it. Okay. Now, this blue colored portion, boys and girls, is the mighty stroma. Well, it is nothing but the matrix. It is called as stroma in chloroplast. This is very special. Now, to our surprise, this stroma has very special membranous system within it. Yeah, those are called as very systematically stacked upon one another, like idlis. Imagine you put some 10 idlis one after the other, exactly like that. Yeah, these stacks in fact connected with elongated membranes with other stacks also. I'm just showing two. Beautiful. So, boys and girls, this entire stack is called as, answers in the chat box. Don't shy away, it's your exam. This stack is called as the granum. It is called as the granum. Yes, ma'am. Sounds familiar. Every idli of the stack, every membranous sac that you see is going to be called as, answers in the chat box, is going to be called as thylakoid. So this means several thylakoids stacked upon one another make a granum, plural being grana. Yes, this thylakoid is called as the structural and functional unit. Structural and functional unit, and write it in your notes, of photosynthesis, or you can say of chloroplast. Not photosynthesis, of chloroplast. Why, ma'am? Why are we calling it? We call cell as the structural and functional unit of the body because cells are coming together. The basic unit is cell and then organization is happening and we get this entire body. Similarly, thylakoids are going to make this entire machinery, every thylakoid, because actually the pigments of photosynthesis are studied in thylakoid, and that is called as the photosystems, which we are going to study in a few minutes. Other than that, this stroma, as your NCERT shows, has these starch particles. Why, ma'am? Why starch particles? This looks like dosa, isn't it? Set dosa, I think. Yeah, I'm cooking these days. I think that's why. So, and I eat a lot of, yeah. Why starch? Because actually chloroplast in the stroma, we just saw, does dark reaction, forms glucose. What is the stored form of food in plants? It is starch. So, starch granules. Everything has a reason, na? Let's go further. Now, this organelle also has something very special. What did I just draw? Answers in the chat box. Come on, people. Yeah. This is nothing but a special blessing to this organelle by God, its own double-stranded, circular, but naked. naked DNA. What do I understand by naked DNA? It's just like a prokaryotic DNA, na baba? It's just like a prokaryotic DNA. Naked because histone proteins are absent. You studied all this. Come on. Don't act like I don't know. Okay? So, this confirms, sort of adheres to the theory that chloroplasts and mitochondria were initially prokaryotic cells. I don't know if you've studied that in evolution. Which got specialized and became organelles of a eukaryotic cell. Other than that, you also have, would it go? It wouldn't go. Would it go? It would go. You also have its own ribosomes. Now, what kind of ribosomes are this? Quickly, answers in the chat box, everybody. These are 70S ribosomes, boys and girls. These are 70S ribosomes, ma'am. Also prokaryotic ribosomes. Prokaryotic ribosomes. So now this guy has ample amount of machinery to undergo replication on its own. Suddenly I want to do more photosynthesis. Okay, we will replicate. These two things, star 1 and star 2, give the property. What am I going to say? Come on, answers in the chat box. Make me the chloroplast semi-autonomous in nature. Semi-autonomous in nature. Yes, no, kind of, sort of. All good? Happy? All done? Now we have understood the site of photosynthesis. Now what we are going to do? We are going to solve a question from the basics. Answers in the chat box. Not going to leave you just like that. Not happening in my class. Come on, people. Athar Pratap Singh, you have a good name. Madhubala. Hey, some of the names I could be pronouncing wrong. So pardon me for that. You guys have beautiful names. Beautiful mean Sausi, Praveen, Naisha, Satish. Praveen, why are you doing this here? Naisha, what happened, darling? What are you doing? Yeah, I know why I put this question. Yeah, like I said, it's fun playing with your heads. Only because Naisha answered wrong. Oh God, what do I do with you? Okay, darlings, I know biochemical process is also correct, ma'am. Physicochemical process is also correct, ma'am. What do we do? Well, you can't, in NEET exam, like I always say, you have to choose the most appropriate option. Why is physicochemical process the most appropriate option and not biochemical? Listen to me very carefully. You can call respiration also as biochemical process. You can call digestion in my body also as a biochemical process. Baba, a metabolic process where chemical energy, bonds, breaking of bonds, making of bonds is involved is a biochemical process, na baba? An enzymatic process where chemical bonds are involved, chemical energy is involved, enzymes are involved, happening in a living body, living cell is a biochemical process. But photosynthesis involves, interacts with a physical form of energy. I think I said that billion times till now. It's like I say, I sound like a broken record, a broken cassette. Yeah, it's a physicochemical process. What is so difficult in assimilating that? Naisha, learn from my mistake, tricky one. Okay, I would really request if you share this session with everybody, because we are going to see many such eye-openers or jewels as you call it. Okay, now chloroplast is done. Acha, chloroplast is present where? I just included this diagram to open up your eyes to the past. The past is, we have studied in anatomy that mesophyll cell is the special ground tissue. Does it ring a bell? Please tell me it rings a bell in your head. Yeah, that lecture is done in Game of NEET series. If you have not watched it, if that chapter does not make sense to you, you still have the chance to join the Endgame 2.0 batch. Link is given in the description box. Okay. Now, this is the mesophyll tissue. Remember, this is a dicot leaf or a monocot leaf? I don't know. Please tell me. There is palisade, there is spongy. Mesophyll tissue is green in color. Why mesophyll tissue? The name especially is given to the ground tissue system of a leaf because it contains these small units. One mesophyll cell on a good day could contain 300 chloroplasts. Maybe more. Maybe more. Okay. What about this? Answers in the chat box. Everybody. Mayuk, thank you, yeah. Achiever, you achieved it. Yeah, we teachers come with our real names in the class. No, we could just name ourselves differently every day. Hey, I'm Anna Beena. Come on, people. You guys are. It's a sunny, beautiful evening out there. Come on. Very good. So, seems like it was an easy question since all of you are answering correctly. The fluid component. What is the fluid component? What is the fluid component? The stroma that I just draw, blue in color, yeah, has all the enzymes for the dark reaction or the biosynthetic reactions. Did we name it or didn't we? We did, right? In the beginning of the session. That's why I tell you, every moment of the session can give you an MCQ, and that is true for all the sessions that happen with all the teachers. It's not just I. Okay, now the light in photosynthesis. What is so special? There are multiple things involved. There is CO2 involved, we'll speak about that. There is water involved, we'll speak about that. What is so special about light? Sunlight is nothing but the electromagnetic radiations. The electromagnetic radiations. I think you guys know it much more than me because this is done in physics. Yeah, particles travel in waves in electromagnetic radiations, and based on the wavelength, I don't see every component of EM spectrum. Pardon me if I say something wrong because you guys are quite experienced. Yeah. Based on wavelength, this sunlight has various components. I can have cosmic rays, I can have UV rays, I can have infrared rays, I can have radio waves, I can have, I lost it, visible spectrum that makes sense to me. Yeah, the visible spectrum is the one that makes sense to me. Yeah, you have X-rays and whatnot. It is all based on the wavelengths. Now, the visible spectrum that we spoke about, I don't know, you must be reading a different range. From my student life, I remember that in physics we used to study a different range, but in biology, my wavelength of interest is 390 nanometer to around 710 nanometer. Is that clear? 390 to 710. Because around 390, the blue spectrum starts. The violet spectrum starts. Okay. But in photosynthesis, the range which is categorically fixed is the 400 to 700 nanometer. 400 to 700 nanometer. Below 390, I think, correct me if I'm wrong, that's your job. If you go below 390, you will enter UV rays. And if you go above 700 or 710, you will go into infrared region. Am I right? I personally believe there could be more components, we have just not discovered them. Yeah? 400 to 700 nanometer is safe for plants. It can be fatal beyond this. This is called as PAR, question, very, very important MCQ. This is given again in ecology and photosynthesis. This is called as photosynthetically active radiation. Now, out of this 400 and 700 nanometer of visible spectrum, I see something. I am not talking about pigments. What I know from various experiments that we'll be speaking about is this is 400, where I start my spectra, my spectrum. Okay, around this is 500. I see a certain peak here, around 430 to 480 nanometer. Guys, it is always a range here. Whenever you see something like this, even in physics, I'm sure you study a range. It's not like, oh, 400, suddenly the reaction will happen. It'll be like, okay, you know, there is violet, there is indigo, there is blue. Okay, I'm entering the indigo zone. There is a spike. Yeah, the spectrometer will see transient spikes. It's called transient spike. We'll talk more about it in action spectrum. And then there is a major fall. Why? Answers in the chat box. You guys have studied physics. Is this chapter done? Is this chapter done? If you answer wrong, I'm going to ask Kailash sir and Yavar sir, what is happening with these guys? Because after 500 nanometer, around 580, it's a narrow wavelength, you see green color. I am not going to absorb green color because chlorophyll is green, it is going to transmit green color. And then 600 nanometer to 700 nanometer is your region. Correct me if I am wrong. Yellow, orange and red. The spectrometer, the needle will suddenly move in the yellow region, but it will not show a spike. Then I enter the orange region. Ooh, little bit of spike. And when I go to the R region, ooh, it's the maximum spike. Now, ladies and gentlemen, as soon as I cross 700, there will be a major dip. It will be more of a dip than the green region. Why? Because there are pigments other than chlorophyll in my plant body, which will not go to zero even in 500 to 550, 580 nanometer. That's the green wavelength, correct me? That's the green. I'm just sort of scratching my memory over this. Okay, and this is very important. You will burn the chlorophyll. So, more than 700 nanometer, the rate of photosynthesis, is it visible? Don't cry. Yeah, rate of photosynthesis, or I can say oxygen evolution, falls down considerably. Yeah, yes, this is called red dwarf phenomenon. I am going to repeat it when we do action spectra and absorption spectra officially. Just wanted to tell you that light is a very, very important factor in photosynthesis. There you go. There you go. Answers in the chat box. You guys have a mind of your own. Hence, ladies and gentlemen, you can derive it here. You can derive it here that can we write or should we write or would you write blue and red are effective regions for photosynthesis. Does that mean, answers in the chat box, does that mean that other regions of VIBGYOR will have zero rate of photosynthesis? Does it mean? Never ever. Even green portion will not have zero rate of photosynthesis. Make sense? So see, people are chanting Ram, Ram, Ram in the country, you know, today. Laharika, why do you want me to smile, yeah, for no reason? Give me a reason to smile. And that will happen if you guys share this session with many, many people. Don't fight. No, no, no. Don't fight with each other. Physics never strikes immediately. It should. Physics is your rank giving portion. By the way, yesterday a news was doing the rounds about the tiebreaker, right? It's a good news for you. Bio is going to take the lead. For a moment, very honestly, I was sad when this year they changed it to physics, chemistry and biology, because ties happen all the time. Think about it, na baba? 22 lakh plus aspirants. Tie is going to happen. So, they are back to biology. They got some sense. Very good. Because bio is scoring. Oh, don't say such things. Then you guys accuse me. Laharika, thank you so much, darling, but you should learn. You should love what I'm teaching. Because botany is quite a... Okay, bye-bye, take care. I'm not going to look at the chat box. It's been months that I have to buy my glasses to appreciate your messages here. I can see them running, of course. Cool. Let's go further. This you guys answered. It is a very easy question. 402. What could be the confusion? Why did I put this question? Why did I put this question? I think folks end up marking this. Don't do that. Yeah. By the way, I'm curious. What is the range of VIBGYOR that you study in your physics? Come, let's do pigments in photosynthesis. Everybody? Ready? Sure? Alright. Now, although we hear many pigments, chlorophyll A, B, C, D, E, there is A to E. If I talk about my higher plants, then we hear about chlorophyll A and chlorophyll B. Yes? The technique that led to the discovery of pigments, let's write the name of the technique first. It was, NCERT has not highlighted it, kindly highlight it. It was called as paper chromatography. There is a special paper that creates bands of different colors. As you dip it in the chlorophyll that you isolate from a chlorophyll rich leaf, for example spinach. Spinach is very rich in chlorophyll. Okay, and this paper will give you the qualitative bands of these colors. That is called as a chromatogram. That is called as a chromatogram. Now, when I use this paper, I get something which is blue-green in color or brightly green in color. Okay, then I get something that is olive green in color. It's like a sad, melancholy green in color. Okay, olive green in color. You can answer in the chat box. There is no tax. There is no cost. Which pigment is going to color blue-green? Which pigment is going to create a band of olive green? Then I get something which is yellowish, brownish, like autumn leaves in color. And I get something which is reddish or orangish in color. Happy? What is that pigment? Yeah, you guys are so wise. Blue-green one is the chlorophyll A. Yes, and the others are chlorophyll B. This is your xanthophyll. Xanthophyll, ma'am, I know, as in fucoxanthin. And the reddish orangish is the carotene. Together, they belong to a class of pigments called as carotenoids. Everybody, called as carotenoids. Okay. Now, let's talk about chlorophyll A and chlorophyll B. Okay. All of these pigments that you see in front of you, all of them are fat soluble pigments or the lipid soluble pigments. Okay. Then you should hear a name from somewhere called as anthocyanins. Now this is a previous year question that broke heart of many people. All these pigments cause negative marking. All these pigments are present in chloroplast. But this one being water soluble, like how you study fat soluble, water soluble vitamins, yes? So water soluble is present in vacuole. Please make a note of this. Please don't let yourself go for negative marking. Okay? All of these are present in chloroplast, especially thylakoid. Now, boys and girls, chlorophyll A is called as the universal pigment. Why? I am present everywhere. You talk about cyanobacteria, chlorophyll A. You talk about euglena, chlorophyll A. You talk about, okay, let's leave fungus. She's rather notorious. Talk about all the algae, chlorophyll A. Yeah, biological classification has been done in endgame batch. It is going to be repeated in endgame 2.0. It's a difficult chapter. We will do it. We will make the handwritten notes. Subscribe to, click on the link in the description box. I think I'm going to start saying this in my sleep. Click on the link in the description box and subscribe to Unacademy NEET English channel right now. Okay, now, and you can follow my profile also on the platform so that you get notified of various classes. Now people, this is not the only reason why I call chlorophyll A as the primary pigment. Let's classify these pigments. Chlorophyll A is called as the primary pigment. Why? Answers in the chat box, everybody. Why do I call it primary pigment? There's a difference. I call it universal because it's present everywhere. I call it primary because reason number one, maximum in amount. Maximum in amount. Chlorophyll B that you see here, this guy very close to chlorophyll A structurally also, is 1/4 the total chlorophyll amount of a chloroplast. If you didn't know, if you're thinking that chlorophyll B should be the primary pigment too, then it is taking part in the primary, takes part. This is not given in NCERT clearly. Whatever I'm going to say in today's class is going to be from NCERT. You might feel ma'am is teaching outside NCERT, but after we will do NCERT decoding. This is one chapter that is very close to my heart in terms of NCERT decoding. Yeah, it's very special. Okay, so takes part in primary reaction of photosynthesis. What is the primary reaction of photosynthesis? What kick starts this metabolic process is trapping the light. This guy does it because for the initiated ones, it forms reaction centers. It forms reaction center. What am I talking about? Who will tell me? Who will tell me what is a reaction center? Clear? Is this clear? So that is why this is the primary pigment. And chlorophyll B, carotenoids, that includes carotens and xanthophylls both. Yeah, they are called as accessory pigments or shield pigments. Shield pigments. Why are they called so? Well, ladies and gentlemen, these pigments are going to, the reason is they are going to absorb different wavelengths in mid region of Vibgyor, in mid region of visible spectrum. Yeah, that is why rate of photosynthesis can fall down, but it's not zero. You will see the spikes where chlorophyll A is active. Now, not only this, they will hand over the energy that these will absorb to chlorophyll A. Absorb different wavelengths in mid region of visible spectrum and transfer the energy through ESR, electron spin resonance. Second reason is they will shield chlorophyll A. If you put the plant in very strong light, something called as photooxidation or solarization happens. Okay, so chlorophyll A reaction center that we are going to see in a few minutes is surrounded by these molecules. Now, what is very amusing is the chemistry of it. The carotenoids have conjugate bonds, conjugate double bonds. You guys would know better. What do I know? I think this is organic chemistry. Yeah, these bonds and all we study in organic. I'm very good in chemistry. I just don't remember now. Like you guys never remember what I ask, only when I ask. So what happens is, people who already know, and I'm going to repeat it, photolysis of water is one of the very stalking, very significant event during photosynthesis. That nascent oxygen which is produced, this happens, this happens. This nascent oxygen can easily burn or oxidize chlorophyll A molecule. But carotenoids having these bonds, you would know better. I am repeating, I am not going to explain how this happens. Convert this nascent oxygen into molecular oxygen. Okay? Convert into molecular oxygen, thereby preventing the, and that is why they are called as shield pigments. With me, everybody, everybody, everybody. Yeah, everybody is learning in the world, no? Masters are saying, hey, they are called shield pigments, accessory pigments because they prevent photooxidation. I am telling you the reason of it, so that you don't have to mug it up. What is wrong? In lower organisms, in cyanobacteria, you have chlorophyll A and B. But you have phycobilins. Remember phycobilisomes I taught in biological classification. Phycobilisomes, chromatophores. Yeah. So they will have phycobilins. Phycocyanins are just like anthocyanins. Phycoerythrin is even present in red algae. Those are also water soluble pigments. Yeah, just letting you know what are the different kinds of pigments. Now we'll do the structure of chlorophyll. Before that, I want you to solve a question from NEET 2023. Everybody, answers in the chat box. Come on. Oh God. Answers in the chat box and share the session with everybody. Everybody is sure about one? Let's do this. You can expect, if you're getting match the following in 2023, 2024 is going to be full of, I'm telling you, it's going to be a moderate to difficult paper, not scaring you, telling you the reality. Chlorophyll A on paper chromatography looked like blue-green in color. Okay, ma'am. Chlorophyll B looked like yellow-green in color. Okay, ma'am. Xanthophyll looked like... a question to you. This is rather in zoology. Which is the most common carotene? Which is the most common carotene? Which you convert, which your body no, not going to give you the answer. Which is essential for your eyes also. Come on. Yeah, if you guys were sleeping till now. I repeat my question. Which is the most common carotene? Which is the most common carotene that your body also converts to something which is good for your eyes? Ha ha ha. Xanthophyll is yellow in color. Carotenoid is yellow to yellow orange, as in carrots, orange carrots, red carrots. What causes the red color of tomato or red chili? Tell me, come on. These are all questions. This is not general knowledge. Structure of chlorophyll? Ma'am, it is not in our syllabus, it is not in NCERT. I am just showing the structure of chlorophyll here to tell you all the possible MCQs, and you try to mug it up without looking at the structure. I should be scared of it. This is the most scary structure that anybody could see. Okay, let's look at this. So, we say that structure of chlorophyll, and here I am talking about chlorophyll A and B, since they are so closely related. It's called as the tadpole structure. Question number 1. I am going to just give you the questions here. Not fond of giving you extra information. But you can't just try to locate every line in NCERT. My job is to decode NCERT and to make NCERT easy for you. It's a tadpole structure. That is, it has the head and the tail. Tadpole is aquatic, right? The head is a porphyrin head. Question. Porphyrin head. Yes, ma'am? The porphyrin head that you see here. And the tail is a phytol tail. The porphyrin head, have a careful look, has the porphyrin ring. 4 porphyrin. The porphyrin rings. How many? 4 in number. Every ring, ladies and gentlemen, is made up of 4 carbon atoms. Do you agree? Correct me if I am wrong. 4 carbon atoms and 1 nitrogen each ring. There you go. in the inner part, isn't it? So let's make an account of it. This is a asked question. 4 pyrrole rings. Okay? And what I see here is nitrogen is holding on to a central magnesium. This is my favorite question. This magnesium is atomic in nature. Yeah, I think your NCERT says it, non-ionic. You know why this is important? Have you ever wondered why the textbook is categorically mentioning that this magnesium is atomic in nature? We never applied our brains to it. Because when I change this magnesium, when this magnesium loses the electron, then only things happen. The idea is to bring stability from instability. Okay? Make a note of that because that is going to help you in light reaction. What else do I see? Let's notice it together. 4 pyrrole rings, and I want you to write it categorically that there is a central atomic magnesium. That is why, although ma'am, mineral nutrition is not in our syllabus, out of the window. If he'll ask a question, which of the following element or mineral is essential for chlorophyll formation? Nitrogen and magnesium, both, their deficiency, both macronutrients. Then he would say, hey, I didn't go out of the syllabus. It is very much in your photosynthesis, and you guys will come out of the exam center crying. The question was outside the syllabus. Yeah, so the boundaries are not so definite. If there is deficiency of nitrogen, achlorosis, the leaf will lose its green color, eventually photosynthesis, eventually necrosis, eventually death. With me everybody? So we've written that. Now I also see these external carbons here. That is very interesting to me. A 1 and a 2 and a 3 and a 4 and a 5 and a 6. Where are you? Yeah, so these are external carbons, aren't they? I can locate, this is the 6th carbon, 7th and 8th. I somehow see, ladies and gentlemen, that there is presence of, can you see it on your screens? There is presence of methyl group here. You see that on the 3rd carbon, 8th carbon, 1st carbon. What is important in my botany is that very frequently asked question here. Can't say this. Do you see this methyl group on 3rd carbon in the pyrrole ring? There is a methyl group in chlorophyll A. Yes, ma'am. And it is replaced by an aldehyde group, CHO. CHO group. What do you call it? Formaldehyde? I could sound like a cuckoo when it comes to chemistry. My physics is strong. It's okay. Everybody lives in a dream world, no? Okay. So, for CHO group on 3rd carbon. Are we together? Ladies and gentlemen, this causes difference in the chemical nature. Now, if you want to dig deeper, a few years back, this question I don't expect in NEET, but the difference is that chlorophyll A molecule becomes more soluble in ether or petroleum. But chlorophyll B will be not soluble, not so soluble. You would require methyl alcohol. It will be more soluble in methyl alcohol. The mechanics of it, do your chemistry well. Do you want me to write it? Do you want me to write it? Yes? Interesting, right? This question is very important. Happy? Should we do the formula as well? I think we should do the formula. I could forget it. Anybody? It's a long goddamn formula of chlorophyll A, C55. What is the formula, people? Anybody? I'm forgetting it. 74? I think I lost it. Is it H or let me look into it here. Do you have the formula? It is 4 nitrogen clearly and 1 magnesium clearly. Carbon atoms, I'm not sure. I'll have to turn a lot of pages to get there. I don't know where I have it. Is this correct? Let me know. Is this the correct formula, people? H72. Okay, Anand, it is H72. Sorry, H72. He has not asked the formula since a lot of years. Not expecting, but still. Rest is correct. Rest is correct. Ooh, kudos. Now, I think this one in chlorophyll B, for chlorophyll B goes to carbon atom remains the same, H70. I remember crying looking at this formula here. We used to do it. Is this correct? Could you check please? People are spamming. Yay. Mayuk. Chlorophyll हो गया यार पिछले जन्म में. अभी chlorophyll B का बताओ. Am I correct? Ma'am, we also don't know. You also don't know. Happy world we live in. I could actually pop out good, no? Happy? Healthy? Cool, people, let's get to the next point. Oops, next point is a question. Read the question. The main difference between chlorophyll A and B is. Answers in the chat box. Everybody sure? Varshini, Ramesh, where are others? Chat GPT. Mayuk, Dharanya, what a beautiful name. Made my day. Satish, Mandala, Jyoti. Good. Seems like an easy question. The main difference between chlorophyll A and B is chlorophyll A is a linear chain compound and B is a branch chain compound. Chlorophyll A has no magnesium ion in center of the molecule. In chlorophyll A, both don't. There is CH3 where it is, okay, you got it. Somebody could mark all of the above also. It will be unfortunate. Let's get to action and absorption spectrum, the easiest part of the chapter. Now, boys and girls, I've taken the graph from your mighty NCERT. We all love NCERT. Once in the chat box, I want everybody to write NCERT. We love NCERT. You guys, you badly need to fall in love with this book. Now, We are decoding the action and absorption spectrum. Before that, I want you to understand what is the difference between the both. Just the definitions. See, absorption spectrum is a quantitative measure. Both are mathematical expressions, both are graphs, both are measurements of something. But this is quantitative measure of amount of light, absorbed at different wavelengths, Cool. Action is action, the real action. What is the action? Photosynthesis is my major action. Yes, no, kind of. So, it is qualitative measurement. Yeah, this could be a little oversized. Qualitative measurement, or I am measuring the rate of the process. Rate, or you can measure in terms of oxygen evolution. It's very easy to measure the oxygen evolution. Most of the scientists, when they study about when they do the qualitative analysis of photosynthesis, they quickly go to oxygen. Quite visible, you can easily measure it. Spectrometers are used. For spectrum, the device is spectrometer. Easy, ma'am. Now let's decode the graph together. Come, let's decode the graph together. Yeah, if you, I want you to track chlorophyll A first. Could you do that? This is chlorophyll A. This is chlorophyll A. Let's look at this portion. Ma'am said a while ago that 400, I am going to start from 400. I am not going to touch region below 400 nanometer, not allowed. I am scared to go into the UV region. If you see 400, this is 500. After 500, green region starts. Where do you see the peak? Around 450. But you have to, you see, this is the entire region. That is why you cannot pinpoint a wavelength, Baba. You say that blue region is most effective because this is the peak. But it starts after 400, little bit in violet, a little more in indigo. But maximum, you always use the word, NCERT says it, maxima. Okay, you always use maximum. Okay, it goes to, chlorophyll A is quite serious. He goes to kind of 0 in the green region. Now, here sort of, do you see that? This is the starting of 600. I think NCERT has marked the wavelengths. Why am I doing it? 600, and this is exactly 700 people. Can you appreciate? Yes, ma'am. I see the starting of the peak. The transient increase in rate I see from 600 because this is the your region. Okay, but maxima will be reached in the red region around 680 nanometer. I reach, if you ask me pinpointedly, the range is very 680 to 700. Some authors say 710 also. There is a drop after 700 nanometer, and a gentleman called Emerson identified this. Emerson's effect, he said, he actually gave the first action spectrum. First action spectrum was given by Emerson. Previous year question. He said, hello, after 700, don't burn the chlorophyll. Don't be greedy. Just because you see a peak, don't be greedy. Okay? So this is chlorophyll A, boys and girls. Emerson effect or red drop phenomenon. red drop phenomenon. Make a note of it, extremely important. Let's dig deeper. Eyes on the screen for a while, for a minute or so, not on me. If you see chlorophyll A, it sees a peak in blue region. In the same blue region, up until 500 nanometer, there are other peaks also. This is for chlorophyll B. This is for chlorophyll B. This yellow one is carotenoids. But if I go to the red region, eyes on the screen, if I go to the red region 600 to 700 nanometer, let's call it your region. Not you and I, your. Your is yellow, orange, red. I see only chlorophyll A showing a significant peak. With me on this? So, a few moments ago, we wrote a statement that blue and red regions are the most effective regions of photosynthesis. Since you guys are making such serious notes, you would have written that. Now, I am going to add a statement which you can add in your NCERT, that red region is the most efficient region of photosynthesis, because the main guy, the hero of the movie, that is chlorophyll A, is making an activity in red region. And those of you who know it a little bit better, Photosystems yaar, 680, 700. So blue gets recognition, blue spectrum gets recognition because all the pigments are active in blue region. Wow, very nice, thank you very much. Yes, blue region is amazing. But the problem is their quantity is much less than chlorophyll A. He is the hero of the story. With me? So we are going to add that. Where do we add that? We'll add that on the next slide. Oh, there's no space. Let's write it here. I want you to add it around this diagram in NCERT if you're making a note. Red region is the most, the word here, the key word is efficient region. For photosynthesis. Why, ma'am? Because chlorophyll A absorbs maximum light here. He becomes really active in red region. But it doesn't mean that you can keep burning him with red light. Okay? Let's go back. We are not done. We're not done. Let's also give some eye to, let's choose this one. Yeah, let's go to chlorophyll B here. Eyes on the screen once again. Eyes on the screen once again. I know you're busy with your devices. There you go. Track this guy. It has a greater peak. Can you appreciate this green color? Not so much. This chlorophyll B shows you a peak, a greater peak, ma'am, in the blue region. Ma'am, why then chlorophyll B is not the primary pigment? It is working harder. It is showing a greater peak in absorption. It is absorbing. Poor guy is 1/4 the total amount. The hero of the story is lazing around. Chlorophyll B is absorbing greater light in blue region, ma'am. It should be the primary pigment. But that's not it. Look at the red region. A lower peak. Okay, and that is why chlorophyll A is the primary pigment. Amount is more, and overall quantity, the net, it is always the net quantity, net rate. What happens at the end? You prepare as much as you want today. You worked hard for 2 years, 1.5 years. That's what teachers tell you, right? In the last 3 months, you're overconfident or underconfident. Both the sides of the coin. I don't know anything. I can't do anything. I'm at zero. I cannot work. This is not going to work. Things are against me. I know everything. I'm already scoring 700 in my mock test. I don't need any preparation or revision. What matters on the exam day is going to decide your results. So net absorption is more with chlorophyll A. If you look at these yellow pigments, the carotenoids, yeah, they are also active in the blue red. But do you see, the other pigments will cause some absorption in the green spectra also. Luckily for us, absorption and action spectra almost overlap each other. Do you see there is no zero here in the green region? Okay people. Now NCERT has been nice enough to give us the wavelengths. This is what I was saying once again. Everybody. You made the diagram clear, ma'am. Thank you so much. Looking like a wow. The diagram should look like a wow, yaar. I am going to look the way my genetics are and then die one day. You should become doctors. That's all that matters. Is this clear, people? Thank you, Satish. Lot many diagrams are going to become clear with me. That's what I stand here for. Akshita. Who wants Pankhuri ma'am to take zoology in her? Guys, don't miss classes in Endgame 2.0. If you haven't joined, it's not just I. The kind of combination of teachers that has happened, things happen, yes? All are super amazing. If I had to study physics, it was my exam, I would study from Yawar sir and Kailash sir. If I had to study zoology, I would do it with Ambika ma'am. If I had to study botany, I would do it with Pankhuri ma'am. Cool. Guys, do you want me to repeat the diagram? You know, after all these years of teaching, the repetition part comes in the personality. The other day somebody was telling me, why are you repeating the same thing again and again? You guys are to blame. Since I repeat so much in my classes, the same thing again and again, in my usual life also, I end up telling people the same thing 2-3 times here. I missed chemistry. Yeah, if I want to study chemistry, I would do it from HSP sir and Vaseem sir. Anything else? I did not miss any legends. Okay. Who am I to do that? Now don't make me repeat that also. Oh God, you guys are something, aren't you? You know how to play with my head. Don't think I don't know. Okay, let's get to the point now. Do I have something more to tell you? I think I do. I do. There's a sense of completion that comes with the topic. Okay, let's revise this. I start from 400. I take it till 500. Please understand this is the green region, green wavelengths. I see a peak here. I see a peak here around 450 to 500. Nobody will ask you the wavelengths. Okay. The qualitative measure or the action spectrum is overlapping. This is for chlorophyll A. He is the primary pigment. He is the hero of the story. Why? Because poor guy is absorbing more in the red region also. This is the region. Boys and girls, yes, now I remember the point that I was sort of struggling to remember. Yeah, Emerson came up with another theory. He said, boys and girls, what do you think would be the correct way to enhance the rate of photosynthesis? Yeah, and I asked this from you. should I give the plant wavelength of only blue region or only red region, or should I give a mix of all? Should it? I know red region is the most effective one. My hero is active there. So should I give only the red wavelength? You know, every day I get up in the morning and I'm like, okay, shoot 600 to 700, shoot. Photosynthesis will happen. Or should I give a mix of, let's say, after green region, or maybe some days green region also, and a little bit of indigo and violet, mix it up a little bit. What do you think? Answers in the, if you think that you can stop thinking with me, come on people, mix, sure. Mixed, sure, common sense, yes. So Emerson said, don't be greedy, don't be impractical. A mix of short and long wavelengths, enhances net rate of photosynthesis, not at the time, the moment you are measuring it. Ma'am, Saucy is like, ma'am, I studied 12 hours today. Then shoot the messages to all the teachers. Bombard the Telegram group. I studied 12 hours a day. And rest of the days, ma'am, I know you guys do that. Ma'am, there was a birthday party, there was a marriage function. This person said this to me, this happened. I didn't study at all. It is a net rate. So he's saying, if you give only the red wavelengths, maybe there will be a sudden spike. But what are you concerned about? You are concerned about the net rate of photosynthesis. So give a mix. This is called as Emerson's enhancement effect. This is out of syllabus. I'm sorry, I couldn't contain it. I just realized that it's not. Red drop is in the syllabus. That is given in NCERT. A mix of short and long wavelength enhances net rate of photosynthesis. Okay, but it's so easy and palatable. This is called as Emerson's enhancement effect. Your NCERT has a lot of space here. I should open NCERT here somewhere. What truth got exposed? Which truth are you talking about? Why are you guys always troubling me? Good, no? You guys are not sharing the session with anybody. I know. Don't think I don't know. Anand, good to see you in the class. We all were missing you a lot. There's a question. Come on, if you thought I'm going to be the one saying everything here. People, answers in the chat box. Let me be the parrot. Alina, what happened? Ash, I don't even remember here. Okay, thank you. Represented below is the graph showing action spectrum of photosynthesis. Who gave the first action spectrum? This question is important. Superimposed on absorption spectrum. See, he's taken a diagrammatic question. Which one of the following is correct for this? From photosynthesis, good news is I gave you some facts about this chapter. I'm going to repeat them. This question will give you 5 MCQs in 2024. This chapter will give you 5 MCQs in 2024. This chapter has a very high retention because there is nothing to mug up. There is a lot to understand. It's technical. Third, if you do not decode NCERT of this chapter, the accuracy of this chapter will be reduced to a great extent because the examiner asks the questions from NCERT lines as it is, and they are very dense and ambiguous. Fourth, I forgot. The difficulty level of the question from photosynthesis every year from what I have analyzed is ranging from easy to moderate. Since NEET has started, it is easy to moderate. There is a bee trying to come into my studio. Oh, darling. Okay. There is a complete one-to-one overlap between the absorption and absorption action spectrum. Is that correct? That seems correct. By this overlapping, it can be concluded that chlorophyll A is the chief pigment of photosynthesis. Actually, there is no complete one-to-one overlap, right? There is no complete one-to-one overlap. This overlapping shows that only chlorophyll A absorbs the entire light energy. You could consider 1 also as correct, 2 also as correct, but 2 is more correct. That is more evident. There is no one-to-one overlap, means there is no space between them, right? Isn't it? This shows that chlorophyll A is the primary pigment. These graphs show that photosynthesis occurs only in the wavelength of blue and red light. I think I have spent 30 minutes to clear out this misnomer that people carry. It is not only blue and red light. Are we clear? Is it digested? Everybody. Now, next question, answers in the chat box. Answers in the chat box, everybody. People are saying 1, 2. All the following regarding the role of xanthophylls and carotenoids in photosynthesis are correct, except, I love such kind of questions which create a challenge, except they act as accessory pigments. Yes, ma'am. Their peak absorption is in blue and red regions of Whitgier. They enable a wider range of wavelengths of incoming light to be utilized. Yes. They protect the, yes. This becomes incorrect. I told you the chemistry behind it. How they protect chlorophyll A from photooxidation. They have conjugate. What are conjugate double bonds? Could anybody explain? Next. Photosystems, ladies and gentlemen. Now we get down to something serious. See, we are taking one step at a time. The way to read this chapter is 1, 2, 3, cha, cha, cha. You do the basics, then you go to the advanced. You just don't take out one topic. You can't understand light reaction till you've understood the role of light, till you've understood photosystems. Yes? Now you'll understand photosystems. If I say that chlorophyll A is the chief pigment, okay, and other are accessory pigments. What does it really mean? And if I say that thylakoids or grana contain the photosynthetic pigments, so is it just like a thylakoid is like a bag carrying the pigments? Where are the accessory pigments present? Where is this chief hero of the story present? So what we are going to do? We are going to take out one thylakoid. We are going to take out one granum out of the chloroplast. Can we do that? Take out one granum. Or let me make it fancy. Thylakoid, 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 thylakoid. Ha ha. Stroma lamellae, did we mark that? Stroma lamellae, did we mark? If I missed it, it's bad. Stroma lamellae, I don't think we marked. Where is stroma lamellae? Show me stroma lamellae. See, we didn't mark. Let's mark it. This elongated membrane, it's the same thing here. Think about a thylakoid that elongates itself to connect to grana. This here is called as you know, in biology anyway, for an elongated membrane we use the term lamellae, lamellar structure, and since it is present in stroma we call it stroma lamellae. Botany is the easiest subject on the planet here. Stroma lamellae, okay. Now this has importance as we go here. Yeah, so this is the stroma lamellae and I have the other granum. Happy? Okay, now focus on this, eyes on the screen everybody. These regions which are pressed against each other, thylakoid number 1, thylakoid number 2, in between both of them, these are called as the oppressed regions. Oppressed regions of thylakoid. Since we are pressed together, how easy could botany be? Okay. And these free margins that you see, there you go. In fact, this one also, this also, this is called as the unoppressed region. Are we together? Okay, good. Yes. Now what happens? Let's get to the next concept now. If I say something is a system, it means it has individual units. Okay. So what is a photosystem? Technically, conceptually. Yeah, then we'll come back to the diagram. A photosystem is a system of vis-a-vis number 1. Can you see? Yes. A reaction center that I've been calling out since evening, also called as the photocenter. It consists of something called as LHC or the light harvesting complex. I see people using photosystem and LHC synonymously. Kindly don't do that. Light harvesting system. Which are nothing structurally, they are pigment and protein complex. Pigment and protein complex. Together with me. Third thing is electron carriers. This is actually, photosynthesis is actually a game of, Kelvin said this. It is nothing but a game of a dance of electrons. Okay, electron carriers. This is the machine. So now you have introduced the mighty pigments that Vibgyor interacts with into this machinery called as photosystem. With me everybody, let's talk about the next concept right here. I am going to draw another diagram that is given in your NCERT. If this is the reaction center, something like this is given in your NCERT. Yes? Agreed? This reaction center consists of a chlorophyll A molecule. The photocenter consists of a single chlorophyll A molecule. That is what NCERT says. Now theories have come out that it's a dimer. Like I said, overall in science, especially in the chapter of experimental biology, things will never be black and white. Discoveries will keep happening. The emerging branch is quantum physics, which has defied so many laws of physics already present. So science is just, you keep learning. It's a bottomless pit. This chlorophyll A is the reaction center. He is going to interact with the blue and red region or whatever you've studied. These guys are going to transfer the energy through electron spin resonance. Ooh, what a fancy term. You guys know it. I'm leaving it on you. To this guy and shield it. So these are the LHCs here. And this is the reaction center. This reaction center is going to be associated with complex molecules, yeah, called as the electron carriers. Now people, if reaction center absorbs 680 nanometer, I call it P680. I call it P680. Absorbs meaning I will only get excited if you give me this energy. Otherwise, I will not get excited. We'll see what excitement means. And if reaction center gets excited only at 700 nanometer, ooh, we are reaching the end of the red region. Didn't we see a peak between 680 and 700? So chlorophyll A molecule is working in that peak region. If I see a peak at 700, then my name is P700. Can we name that? Botany is the easiest subject. These happen, so this name is there. Okay, it is unlike other branches of science. Okay, now ladies and gentlemen, if you are carrying a misconception that what is PS1 and PS2, ma'am? This 1 and 2 is based on discovery, yaar. It is not based on the wavelength. It is based on discovery. On any Monday, Tuesday, Wednesday, this guy is always activated. The wise ones know what I'm saying. But still, I named this one as PS1. Okay, so PS1 is P700 and PS2 is P680. But PS1 was called PS1 because it was discovered before PS2. With me on that? So if somebody says P680, we are referring PS2. If somebody says P700, we are referring PS1. Together, where are they located? Important. Are you very clear what is photosystem? It's rather confusing in NCERT. Nobody explained it to me when I was a student. Okay, now this PS2 is located in the appraised region. Are we together? This is the appraised region. PS2, 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 PS2. if at all I was listening to myself. Okay, PS1 is what? P700. Baba, PS1 is what? Let's get back to the basics. I'm not leaving you. Come. If reaction center or chlorophyll A molecule gets excited with 700 nanometer of light, it is called as P700. And since it was discovered prior to PS1, it is called PS1. That is located here. PS1, wherever it sees free surface. And even in stroma lamellae, PS1 is present. Very important question here. Affirmative? Good? Digested? No constipation and diarrhea at this level. Otherwise, you're not going to get the rest of the chapter. That's the thing with photosynthesis. There is no trail of concepts that you make in your head and then you struggle. You consider photosystem is different, light reaction is different, dark reaction is different. It's one after the another. How is it going? What is the memorable incident there? Memories are very good. They drive us. Oh. Thank you very much. Thank you very much. More the wires, more I get this sense of checking on them again and again, if everything is all right. Yeah, I have to tell you something more. Do you see these outer surfaces of grana here? There is a particle present here. It doesn't look the way I am drawing it. It is just to create a distinction. You know what this is? One of my I have to stop saying that. This particle, ladies and gentlemen, is called as the coupling factor. Who will tell me in the chat box? Let's see who is doing what in their preparation. What is a coupling factor? It is nothing but ATP synthase enzyme, and as is the name, this enzyme is going to form ATP. Didn't we promise that in light reaction, ma'am? You promised at 5 p.m. that light reaction should give me ATP and NADPH. That is the assimilatory power, and I am going to use it in fixing carbon dioxide to carbohydrate. Well, we are slowly reaching there. It's very bad to jump onto things. Walk the walk. Okay? So as we walk the walk, this coupling factor is also located on thylakoids. Who would have thought? He's doing the main job. This is the same thing that you study in cell. Maybe you would have studied with respect to mitochondria. Okay? So here it is called CF0CF1 particle with the head and the tail. With the head and the tail. Or oxysomes. It's the same thing here, because mitochondria and chloroplast both have this superpower You would have thought that there is one superpower, both are semi-autonomous. Both have the superpower of causing the formation of ATP, also called as chemiosmosis. Now be honest with me and tell me in the chat box how many of you have never understood chemiosmosis as is given in NCERT. If you have understood, very good. If you have not understood, even more good. Okay. So this is what you can call them, Fernandez-Moran particles, oxysomes, or tennis racket particles. In fact, I think I have tennis racket. I'll show it to you. Fernandez-Moran is because of the gentleman who discovered it. It's the same thing. Yeah, let's see in the chat box how many are struggling with chemiosmosis. Me. Okay, people, let's go further then. You want to make it easy with me? Then solve a question. Solve a question. The more you face the devil, more familiar it becomes. So solve the questions. The exam is about solving the questions here. You can escape from it today, but the exam is going to be about solving questions. Come on, everybody is answering correctly. The reaction center in PS2 has an absorption maxima at 680 nanometer. Good. Yes, but why it is called PS2 is not based on 680 nanometer. Ma'am, it is absorbing less wavelength, that is why we call it PS2. No assumptions in science, no assumptions in botany. I'll not let you do that. Come on. Light reaction. I was waiting for light reaction. Yeah, it's super fun to teach light reaction. You know what? One day I saw a dream that I forgot everything in botany. All the content stored in my head, I forgot about it. Some people, today somebody accused me that I forgot their birthday. That is why I forget birthday. You have to contain so much, yeah? Photosystem, why it is called PS1, why it's called PS2. That's why I don't remember birthdays. Yeah? If you are in the class. Okay. So, light reaction. Well, coming to the point, it is called as photophosphorylation. Oh my God, what just happened? Such a big word. Let's make it easy. Phospho means phosphate group, inorganic phosphate group. Rylation means addition. Whenever I am adding phosphate group, it is called phosphorylation. We know that ATP, adenosine triphosphate, I need not 1, 2, but for that energy molecule, the universal energy molecule which is driving this planet, I need phosphate, 3 phosphates. If it happens in the presence of light, it is called as photophosphorylation. That is my aim. Okay. There is substrate level phosphorylation also. You see it in respiration, don't you? Do you? And who cares about respiration? Come on, what are you talking about? Yeah, you see oxidative phosphorylation in electron transport chain happening through oxidation reduction, oxidation reduction, oxidation reduction. Mitochondria? No? Yes? And this is photophosphorylation. This process claims to give me ATP, and ATP said, please help me, give me one more reducing power. It gives NADPH, not NADH, NADPH. In the same reaction, I am done with evolving oxygen. Okay, so these products are certainly going to be produced in light reaction. The site of this reaction is the thylakoid. If the site is thylakoid, what do you think? Should we draw a thylakoid? Should we dissect the thylakoid? Let me just draw the scheme that is given in NCERT, and then we will do it in my way. This process is of two types, non-cyclic, which happens on any given day, and cyclic. We'll see what is the difference. In non-cyclic photophosphorylation, I start with photosystem 2. Okay, ma'am. Now tell me in the chat box how much wavelength of light I need to excite photosystem 2 so that the resonance happens, so that disturbance happens. Come on people, answers in the chat box like there's no tomorrow. Everybody. Thank you so much. Thank you so much. 680 nanometer. So we have our Vidyur, Surya Devta is giving the wavelength of 680 nanometer. 680 nanometer. Now if you remember, I was quite pinpointed about the fact that magnesium is present in the atomic state in the structure of chlorophyll. Yes or no? When this light falls, ladies and gentlemen, it is that magnesium atom which is going to come in the cationic state. The two electrons will shift to the outer orbital, and now they want to be accepted by the nearest electron acceptor. Now you tell me, would I need greater redox potential or lesser redox potential if I want this electron to be accepted? You tell me. What would I know? Oh. You know, in olden times, in ancient times, people used to do this fasting of, it used to be called as Maun Vrat. They wouldn't speak for days and weeks together. Who will answer that? Thank you so much. So, this game is going to be electron moving to greater redox potential. Somebody promising, you come here, you will get stability. Come, come, come. Yeah. So, it is greater or increasing redox potential. Boys and girls, there are two things. One is my movement along the redox potential. Other thing is my direction of movement. Have a look here. Eyes on the screen, not on me. Now when this electron gets excited, it moves uphill here. It moves uphill as well as it moves along increasing redox potential, and the first electron acceptor is mighty. I am writing the short form Pheophytin. Pheophytin. What we are going to do is, we are going to make a note of everything here. What do you think? Good idea? Good idea means good idea. Pheophytin. Do you know what pheophytin is? Do you know what pheophytin is chemically? The chlorophyll structure that you studied with me, right? In the earlier part of the evening. Remember tadpole structure? Remove magnesium from that. It becomes pheophytin. Structurally. This pheophytin is going to transfer this electron. Magnesium had lost 2 electrons. They move uphill. Now they are moving downhill. NCERT has done this blunder. The only person who has read NCERT properly, and I am going to do NCERT decoding of photosynthesis in endgame batch. It says downhill the redox potential. No, the direction of movement is downhill, Baba. but redox potential has to be greater. Correct me if I'm wrong. Chemistry wise. So the next one is plastoquinone. Now this guy is rather interesting. This guy is very interesting. Okay, so PQ stands for plastoquinone. In your NCERT, I am starting with the simple version and then I will show you my version, which is going to do wonders for you. You will understand light reaction and chemiosmotic hypothesis like never before today. But we are doing from the simple version. Let's decode NCERT first to create familiarity. You see something like this. Do you see that happening in NCERT? That here, not here or anywhere else, ATP is formed. So we are labeling it differently. Now the electron seeking stability moves to the next one. Downhill movement, up the redox potential. Yeah, you would say, ma'am, these carriers are not mentioned in light reaction. Why are you doing it with us? It goes to, you will see, it goes to another, a bigger and larger carrier called as cytochrome B6F. You must have heard about it in ETC of mitochondria. You see, these cytochromes or these complexes are proteins, iron, somewhere in some of them copper, sulfur. That is why you can't afford to have deficiency of these mineral elements. Yes, yes, it is out of syllabus. This one is a bigger one. Downhill movement. Okay, only around here ATP is formed. Now boys and girls, I wonder, if magnesium loses 2 electrons and changes into Mg2+, question number 1, could I afford to have this state? Because light of 680 nanometer is falling down. The photons of light are bombarding this reaction center, and magnesium, if it keeps losing electrons, will burn off. My chlorophyll molecule, my chlorophyll A, is going to burn off in seconds, called as solarization or photooxidation of chlorophyll. Also, if these electrons are going up, I need to supply PS2 with electrons to continue the process. So I need a simultaneous process. Now people often ask me, ma'am, does it happen before or does it happen after? Is PS2 getting excited before? Is photo? Simultaneously. Okay, so with this, ladies and gentlemen, a very important process will happen simultaneously, which most of you know is going to keep this promise. Photolysis of water. Water is going to break down and form nascent oxygen. This nascent oxygen, like I told you, carotenoids will not let it reach chlorophyll A molecule, and it will escape as molecular oxygen then and there. Your promise is kept. Thank you very much. These electrons are quickly going to go there. So both the processes happen together. In certain texts you will see, oh, there is photolysis of water that happens. Light falls down. PS2 gets excited. No, they happen together simultaneously. Okay, what is going to happen to these protons is still a question mark. And keep that question. This is the food for thought. Why do I have these protons? They will find a place. Everything finds a place. Now let's complete this trail. Let's complete this trail. From cytochrome B6F, I go further downhill to a copper containing carrier. Anybody in the chat box? Chat box is off now. What is the carrier? It is plastocyanin. It is plastocyanin. Let's write it here, plastocyanin. It is also known as, let's write the previous year questions. Yes? Everybody is getting the point? वापस PQ जाता है और next cytochrome B6. Okay, I like that you're creating a story out of it. Thank you. Talking a lot of sense. Plastocyanin. Plastocyanin is regarded by the examiner as connecting carrier. Connecting carrier. Now guys, I am lost out on space, but if you're taking down the notes, please continue. The trail is important. How am I going to make this space? Well, I'll see. Connecting carrier between PS1 and PS2. Okay. I'm going to take the space from photolysis of water for a while. I'll rewrite it. And please go in the horizontal mode. From plastocyanin, I see a downhill movement to, not downhill, PC and PS1 are located quite at the same level in thylakoid membrane. PS1. This PS1 is going to get excited at what wavelength? Quickly, in the chat box. In the chat box, everybody. Come on! It will get excited at 700 nanometer. It will get excited at 700 nanometer. Isn't it? So this PS1 got its electrons, 2 electrons from PS2. It doesn't need any external source of electrons. He has, what did I say a while ago? Photosystems are made up of, what are they made up of? What are the components? 3 components, whoever is listening. There are so many listening very attentively. There is reaction center which is lying here. There is LHC and there are electron carriers. So his electron carrier is an iron sulfur protein according to NCERT. Leave the new text, you will be asked out of NCERT. New texts are saying special chlorophyll molecule A00A0 FES, iron sulfur protein. Iron sulfur protein gives it to ferrodoxin. Mind you, ferrodoxin chemically is also iron sulfur. Continue on the same page. It's a iron sulfur particle, iron sulfur protein. It has more redox potential, that's all. After ferrodoxin, I go to FNR. What is FNR, ladies and gentlemen? FNR is ferrodoxin NADP reductase enzyme. That simply means I am going to reduce NADP. Poor electron hasn't found his home. Okay, so this is just downhill movement. But here after PS1 I see an uphill movement. Yeah, I don't like the Z scheme that I've made. Okay, we'll see. FNR is going to give the electrons to NADP plus. You give me 2 electrons, Baba. You give me 2 protons. I get converted into NADPH2. NADPH and NADPH2 are one and the same thing. The difference is of you give me 1 electron, 1 proton, or 2 electrons or 2 protons. Since magnesium had lost 2 electrons, I gave 2 electrons and 2 protons. That's all. So all the promises are kept of light reaction. Ha ha. Ha ha. Ha ha. This one is still a puzzle. I don't know. I just believed, ma'am, and I just believe that ATP is getting formed. I don't know how. You have all the right to know how of things. Okay, people? Good till here. Now, why non-cyclic photophosphorylation is called as a Z scheme here? Why is it called a Z scheme? Answers in the chat box, everybody. Thank you, Mayuk. If you would have kept your real name from Bangladesh, I would have loved to speak to you right now. This is the thing about a YouTube class and a dedicated batch. The seriousness or the decorum of the class is not maintained. One more thing I want to tell you before, there is this free scholarship test going on Unacademy. Free scholarship test, yes. A free scholarship test for NEET UG. You share it with your juniors. If somebody is appearing for 2025-2026, they can get massive scholarship on the various courses that Unacademy has to offer. Yeah, you could be with one of your favorite teachers in a dedicated batch. You can win laptops, mobile phones and other exciting rewards. This is the code which is given. You can enroll now, and whenever you are exploring the app, you can use the code PM1 live. And those of you who have your exam in 2024, the alarms are blazing. Use PM1 live to cause the light reaction, that is selection in to cause your uphill movement into selection of 2024 in a government medical college, AIMS Delhi. Yeah, PM1 live is the doorway. There is scholarship up to 90%. Can you guys believe that? Now, ladies and gentlemen, why I've been focusing so much on the direction of movement of electrons? Because it looks like a Z, but that is different from redox potential. It looks like a Z. Now, since I could not cover PS1 and PS2 on the same page, if you have covered PS2 uphill, downhill, PS1 uphill, yes, I become a Z. Once again, I started from PS2, electron went to pheophytin, uphill, right in front of you, look at the screen, yeah, okay, and then it moved downhill to cytochrome B6F, plastocyanin, went to PS1, the electron is right here now, uphill, so this becomes a Z. That's why, owing to the movement of electrons, just the direction of movement, I am called as a Z scheme. I am not very happy with the fact that we don't know how this happened. Ma'am, it happened because of chemiosmosis hypothesis. Agreed. Agreed. We are going to connect light reaction and chemiosmotic hypothesis. Ready, people? So this is the second time I am repeating light reaction so that it becomes clear, like there is no tomorrow. Because sometimes there is no tomorrow. Should we do that? Thank you, Shraddha. God bless you. A break will be given after chemiosmotic hypothesis. Don't think I don't need a break. I am not a robot. I've checked it. Girja Lakshmi, good to have you, darling. Where were you? Please keep your real names in the chat box. I can't spell out funny names here. Cool. Ready for the second time? You guys are lucky. Okay. I don't know why I wrote that. This is my thylakoid. Shraddha, this is the thylakoid. Since you're regular to all the classes. This space, empty space in the thylakoid is called as lumen of thylakoid. And this is called as the membrane of thylakoid. Can I say that this is the outer surface? I am not saying outer membrane, outer surface of thylakoid. And this right here towards the lumen is the inner surface of thylakoid. No chemical formula or physics equation or mathematical algorithm required. Thank you. Now I took a microscope and I made it super big. What am I making big? Because PS2, PS1, coupling factor, all the three things, get serious now, things are going to get serious now, are somewhere studied in the membrane. Let's look at the membrane. Okay, and this is the tiny space, but very, very important space. Okay, so I have just showed you this part, the membrane of the thylakoid. Cool? Okay, ma'am. Say okay. If only you guys say it so sweetly. Alright then, that's all. Done. This is the lumen. Now, don't forget that thylakoid is present in the world of stroma, which has all the enzymes, cations, anions, everything very, very useful. The elixir, if you will. Light reaction starts with which photosystem? Kindly help me out here. As much as I don't like the chat box. Starts with whom? Light reaction starts with PS2. This PS2 said, hey, you know what? Make me very close, place me here. Very close to the lumen, not in the lumen, very close to the lumen. Why? Why should I place you close to the lumen? You'll get to know. I got excited with 680 nanometer, as was the promise. Magnesium gave away 2 electrons, as was the promise. And I go to a carrier. This is written in your NCERT and it is very, very important. I go to a carrier which is located towards the outer surface of the membrane, and my name is Pheophytin. I just met him a while ago, and now PS2 is like, hey, I lost my electron, don't burn me up, give me electrons. You know where the water is lying? In the lumen. In the lumen. How can water particles lie here in the membrane? Okay, so that is why I was requesting a proximity to the lumen. Now, ladies and gentlemen, there we go. Okay, ma'am, if you say so. Okay, ma'am, there we go. All of that paraphernalia. Quickly. And I asked you, what will happen to these protons? As usual, you guys didn't bother to answer. It's between me and my camera now. Well, lumen says, let the electrons go. Lumen is very greedy for protons. He's a greedy guy. He wants to accumulate positive charge. Protons remain or pull up. It's not one water molecule which is going to undergo photolysis, isn't it? This is your photolysis of water. Let's write it somewhere. Why aren't we writing it? Let's write it. Oh, come on, ma'am. Who will do so much of hard work here? Photolysis of water happens where? Lumen. This is the added information that I am giving you. Okay. Protons pull up. Now, eyes on the screen, take a deep breath, everybody. This pheophytin gets these 2 electrons and says, yeah, I'm happy. But he doesn't realize that there's somebody more in need of these electrons with a higher redox potential, and that guy, you know, I marked him differently as plastoquinone. The wise ones know, and this is one of the most confusing lines of NCERT. The electron carrier, which is located towards the outer side of the membrane, now gives or transfers its electrons not to an electron carrier but a proton carrier, which then transfers its electron to an electron carrier located towards the inner side of the membrane. That's what NCERT says in the second paragraph of Chemiosmotic hypothesis on a fresh page, if you see that. Well, if it didn't make sense to you, this is the line of NCERT which I am going to show you now. We will do NCERT decoding, every word, every line in endgame batch. Now, come to plastoquinone. When this guy gets 2 electrons, tumba innocent he is. He is very innocent. Hey, negative charge, yay, I am finally going to be very stable if I get positive charge from somewhere. Now, he's like, Thylakoid, can you give me positive charge? I got negative charge. This guy was not a fool. He waited. He didn't get too excited or happy with a little bit of success. Oh yeah, I scored 650 in this particular mock test. I'm going to score, I'm going to be the topper. No. Don't be overconfident. Test yourself every day. This guy somewhere knew that this is transient happiness. This guy got excited. Thylakoid said, hey, all the positive charge that I try to gather, this lumen greedy guy takes up all the positive charge. I can't have anything. Membrane is like, I don't have any positive charge. So then plastoquinone is like, I know there is a very nice guy. There's a very nice place, stroma. Stroma is quite generous since it has everything. Stroma donates quickly protons equivalent positive charge, and this is the guy who gets reduced. For other electron carriers, we don't say that, and that is why, ladies and gentlemen, NCERT says hydrogen carrier. That's not the actuality of the situation. Nobody is a hydrogen carrier, actually. Because he managed to get positive charge, he gets reduced to PQH2. Plastoquinone becomes plastoquinol. Okay, ma'am, if you say so. Agreed. Saucy, I will kill you. Don't crack the same joke as the batch, as the endgame batch, and make me laugh in this class here. I'm sure there is a class clashing. People are missing some of the most important concepts. Now, this plastoquinone is very happy. He thinks, I'm so stable, I'm reduced. Little does he know that there is somebody lying with downhill movement with a very big or a transmembrane electron carrier called as the cytochrome B6F. He knocks on his door and says, electrons, I need it more. This guy is baffled. He agrees to transfer the electrons to cytochrome B6F. But cytochrome B6F is very intelligent, is very wise. Intelligent is the wrong term. Is very wise. He has learnt from his mistake. He looked around. He saw that, pheophytin had to give his electrons to plastoquinone, I am sure there is somebody who's going to take away these electrons. It's not permanent, nothing is permanent. He takes only those 2 electrons. And that is why in that diagram of what I am drawing is chemiosmotic hypothesis given in pink in your NCERT. Okay, and that is why, ladies and gentlemen, you see in chemiosmotic hypothesis that electron continues, that arrow continues, but protons. Now plastoquinone studied in the membrane. Okay, fine, now what will I do of positive charge? I don't want it. He's very melancholic, he's very sad. If I don't have negative charge, it's okay, I'm very sad. Cytochrome B6F knows that he doesn't have to do anything with H positive. Instead of sending it back to stroma, this lumen here, greedy guy, tells plastoquinone, he's very innocent, no? Pavam, give me a positive charge. I'll keep it. That's his habit. That's who he is. These protons pull up. Already he had protons from water photolysis. So now, plastoquinone is able to give those protons into the lumen. This is not going to happen once. This is going to keep happening. So this guy is becoming deficient in protons. Electrochemical gradient is written in your NCERT and you guys know it. Now this is just what we have just seen, 2 reasons, this and this. I am going to repeat chemiosmotic hypothesis again before the break. We'll do chemiosmotic hypothesis. I am clubbing light reaction in chemiosmotic. Which kind of light reaction is this? This is non-cyclic. And that is why you see ATP formation here in your Z scheme. Because when this pooling happens na baba, the cell gets disturbed. He's like, what is this? Why is lumen being so greedy? Why? This is not right. Balance will be created. Lumen is thinking, hey, I have all the positive charge. Yay. No. Sooner or later, balance is created in the cell, in life. So now, coupling factor that I taught you, the F1, F0 particle becomes activated once this disbalance is created. And that is why, because this guy is a participant to cause the disbalance, we see ATP formation. Because if he didn't send these protons into lumen, this coupling factor or oxysome will not get activated. But I have to do something. Something wrong is happening here. Okay. So on the lumen side, I have the F0 or the tail, and on the stroma side, this is the stroma side, I have F1. Wanted to clear it out. What was our problem? What was itching? The itch was, ma'am, I know how NADPH is created in non-cyclic photophosphorylation. I know how oxygen is created. Okay? But I don't know how is ATP created. And that is why I did all this. Now you continue. Now you continue. Nobody is stopping you. What will happen? Answers in the chat box. The 2 electrons will go to plastocyanin, downhill movement. Plastocyanin is going to give it to PS1. PS1 uphill movement, FES downhill movement, ferrodoxin. Have a look here. Attention everybody. The FNR that we studied a while ago, that is NADP reductase enzyme, is located on the stroma. So ferrodoxin gives the 2 electrons in the stroma. Careful look. Now in the stroma, NADP plus is waiting. It gets 2 electrons and become NADPH2. Ha ha. Meanwhile, let's get back to business. The protons enter here. The protons enter the F0 particle. I got this for you. Somewhere in my closet, it was lying. Yeah, in my previous house, there was a TT table. We used to play. But thank God I had it. Everybody means everybody. This is exactly, that's why they are called tennis racket particles. I am whom? I am the lumen. You are the stroma. You are the good guy. Okay? Everybody is watching. This is the tennis racket. Ball is... okay. Somebody has written a letter. India salutes your immense efforts in helping change education in India forever. Thank you for being the inspiration that you are. Guys, don't send senti messages here. Thank you for all Unacademy team to providing amazing support. Well, lots of love from Bangalore, lots of hugs and blessings, and may only good things come to you. I am not married. What is borax? Can I crack NEET in 4 months? Darling, 4 months are not, darling or dearest, 4 months are not remaining. Time is over. Okay. Okay. So, I am, ma'am is greedy, lumen. You are stroma. This is the F0 particle. I have all the protons. Ha ha. Yes, they are going to enter through the F0. The tail, the foot, if you will. This is where my enzyme is, which is a protein. And proteins are always crying about their configuration, their conformation. Now this is all chemistry. When I'm made to give that accumulated proton to the foot of F1, F0 particle, F0 is the foot, it's 0. And the proton passes through here. Yeah? I need to get the table again. And the proton passes through here. The head will move. Whenever you're playing also, you move first here. You move first here. Yeah? So this F1 particle, it gets disturbed. And the synthase enzyme towards you forms ATP. Forms ATP. Where is my pen? Where is my pen? You with me? The foot, the head contains ATP synthase. ATP synthase, which is going to on the stroma side, ladies and gentlemen, cause this reunion. In the stroma, oxygen left the cell on Wednesday. What day is it today? It's Monday. On the stroma side, through non-cyclic photophosphorylation, I kept my promise and made NADPH2 and ATP. Because the next set of reaction we ascertained quite early in the evening. Do you guys want morning classes like 5 a.m.? I am up at 5 a.m. also, 5 p.m. also. Yeah. Let me know if you want. I don't mind. I hardly get any sleep here. You can let me know. Because the next set of reaction is going to happen in stroma. Conversion of CO2 to C6H12O6, biosynthetic pathway. You solved a question on that, or dark reaction. After the break, we'll do after the break. Don't worry. Don't let your claws come out and then spam the chat box, spam break. I'll give you I also need the break. But let me tell you everything that has to be told. Is it clear? F0, F1 particle coupling factor, because it is coupling ADP and inorganic phosphate on the stroma side. This is called as the hydrogen carrier, or the later on we'll call something else also. This is transmembrane. Yeah, this feels complete. Understood, everybody? Understood? Any problem so far? Let me know. I hope the charging is, yeah, all good? I'll be sticking in bed at 5 a.m. Okay. Do you want the class at 6 a.m.? Like I said, I consume very less sleep. Varshini, if somebody wants to teach me Tamil, I would love to. It's yes. Halima, thank you so much, darling. You can always connect with us at a better scale, that is every day, in the Endgame 2.0 batch. Let me know if you need any help. Okay. Now let's talk about cyclic photophosphorylation, and then we'll take a break. Promise. Even my throat is giving up. Let me know if you're ready in the chat box. Fire in the chat box. Fire in the chat box. No, nah, more. Saucy, change. I need a change. Yeah. Where is Ashwat, Anand, Naisha? Ma'am, we are busy writing notes. So, ladies and gentlemen, one day what happened? Plant said, I don't have enough sunlight. It's quite gloomy. I cannot perform photosynthesis actively because then I'll use more energy. So the other cells, that's what Chloroplast said. The other cell said, bro, we need, whether you want to perform photosynthesis or not, it's okay. But you know, we need energy here. Because we need energy for everything, for respiration, although in respiration you make energy, yes, but in the initial steps you might. Transpiration, translocation, whatever. So the plant said, okay, let's do something. I'll devise a process where I just form ATP. ATP centric process. And that's it. This will continue. And we'll make it cyclic so that in my body ATP formation never stops. Okay? So that is called as cyclic. Simply means that wherever I am starting from, I am getting back there. Till now we have ascertained that all of this phosphorylation is a movement of electrons. Who was moving all this while? Who is jumping from one place to another place? Electron. The only difference is there the electron got incorporated, reduced and made a superpower NADPH. But here the electron gets back to the source. Now ladies and gentlemen, this is common sense. If I am getting back to the source, understand that this electron which started from his home address PS2 never got back there. Eyes on the screen here. My voice is enough. The electron which started from the home address never got back here, yeah? It got to a second home, lived there happily ever after. Hence it is non-cyclic here. This means whether I am starting from PS2 or PS1, I don't know. But I am not going somewhere else. I am getting back to home address. And that simply means that any DPH will not be formed. But the formation of ATP was never dependent on whether the electron is getting incorporated or not. Yes, ATP formation is related to something fixed in the membrane. So that is going to happen. Ma'am, third thing, what about photolysis of water, ma'am? Well, we'll answer that. Okay, let's answer that also. Baba, the purpose of photolysis of water was, PS2 said, my electron is never getting back here. I give back the electron and he goes somewhere else. He's not coming back. Okay? So I need an external source of electron. But as the name suggests, and this without explaining the process, I am just awakening your common sense. This is a very important question, difference between cyclic and non-cyclic photophosphorylation. Baba, the name cyclic only has everything written in it. Don't you think so? Yes? Agreed? I'm going to close the chat box for a while so that I don't miss a point. Okay, cyclic photophosphorylation. Now whatever you have studied with me, let's just jot it down. Can we? No ATP is formed. No NADPH2 is formed. Only ATP. No photolysis of water. That means no oxygen evolution. Oh, there's something that I had to tell you. Yes, it's not given in NCERT, but a previous year question. Yeah. Around here, guys, in this photolysis of water, there is a oxygen evolving complex here. Who will tell me the components of oxygen evolving complex? For photolysis of water, I don't just need 680 nanometer of light or a water molecule. That's not it. Along with the water molecule, I need the help of manganese, chlorine and calcium in the ionic state. Is this the correct ionic state? Kindly help me here. Not sure about manganese. People, is this correct? Manganese 2 is correct. Giving a break in 5.5 minutes. Okay, so this is called as the oxygen evolving complex. Crucial. If your thylakoid doesn't have OEC, oxygen evolution is not going to happen. Okay, so if he will ask, no photolysis of water, no oxygen evolution, no OEC. I don't require OEC here. Tata bye bye. Which photosystem is taking place? Only PS1 takes part. And if only PS1 is taking part, what is the location of cyclic photophosphorylation? Answers in the chat box. Come on here, make my evening better. Showed it to you, yeah? I'm showing it to you everything. What do you think? What will be the location of PS1? What will be the site of cyclic photophosphorylation? Come on. Wherever PS1 is located, that is the unappraised regions and stroma lamellae. Previous year question. Endgame ही endgame है भाई. Stroma lamellae. Stroma lamellae. Also, stroma lamellae lack FNR or the NADP reductase enzyme. I don't need it because I am not sending the electron to the hostel. I don't need it. Good with me? Okay. Now, how is the process? Let's make it PS1. Tell me how many nanometers do I want to excite PS1? What is the wavelength of the light? Everything is stopped. 700, very good. 700 nanometer. Uphill movement of electron. Who is the first acceptor for PS1? Who is the first acceptor? Everybody. Be my darlings. FES. FES. You don't require photolysis of water. Remember that. And here also the rule remains the same. Increasing redox potential. But downhill movement of electron. I go to, who do I go to? I go downhill to ferredoxin. Okay. Ferredoxin. From ferredoxin, I go downhill to, I was supposed to go to FNR. There the twist will happen. There is no FNR. So what do? Do I go back to PS1? No, life is also not that simple. It's good, but not simple. So now I go to, because I need to form ATP, no baba? You will not mug up even a single thing. Have a look at the screen, everybody. If you were thinking, ma'am, why couldn't the electron go back to PS1? Game over. The electron carriers related to PS1 are done here. There is FES, there is ferredoxin, then FNR, and then it used to go to NADP+. There is no FNR, okay fine, send it back. Arey baba, plastoquinone is needed to form ATP. So we said, hey plastoquinone, please come here. And he is so innocent, he is very helping. Like, okay fine, I'll take part in your process also. Yeah. So he goes to plastoquinone. That is electron. Now Plastoquinone is again innocent. He's not learning only. He's like, oh, I got 2 electrons. Hey, give me protons. Okay, stroma says, I'll give you protons. Now Plastoquinone does the same thing. Realizes his mistake because Plastoquinone will give the electrons to cytochrome B6F. He's a big guy. Plastoquinone is going to give the electrons to plastocyanin. And plastocyanin is, I'm chill in life. I know how to serve. I'm related to PS1. He goes and gives the electron to, because PS1 is like, come back. We don't have somebody oxidized waiting for the electron. Give it back to me only, Baba. Let's just keep making ATP. This guy is doing the job. But this time in stroma lamellae, the lumen part of the stroma lamellae will not have pooled up electrons from photolysis of water. So this process also happens when water availability is less. When plant is a little in stress conditions. With me, water availability is less. Plant is like, I want to survive. Don't give me any DPH. I don't want to take part in dark reaction. I want to survive. I want to take care of the sustainability. This is what happens. Yeah. So this guy will have to, because he has taken protons, he'll have to, the lumen will pool up, and again the coupling factor, like I showed you, you can draw as you wish. This is what I showed. I am the lumen, you are the stroma. Cool, looks good, feels good. Ma'am break. Let's solve this question. And then before chemiosmotic hypothesis, although I didn't want to give you a break before chemiosmotic hypothesis, but looks like we can take a break. It is 8:08. Huh? Very good. Khushi, darling, same to you. The chat box has become amusing for me now. Only a few people have answered. This is from 2020. 2020, what kind of paper did we encounter? It was easy. The first year of Corona. 2020. Ready? Tricky hai. This is a tricky question. But during non-cyclic, let me see. During non-cyclic photophosphorylation, when electrons are lost from the reaction center. Oh, this is tricky. You guys want me to, like, this is tricky. Who is saying this is tricky? I'll not scold you, be honest. Who said it's tricky? Oh God. During non-cyclic, I'll take care of that. During non-cyclic photophosphorylation, when electrons are lost from the reaction center. Who's the reaction center, Naisha? In non-cyclic photophosphorylation, who's the reaction center? Is it PS1 or is it PS2? If it's tricky, let's solve it now. What is the source which replaces these electrons? And you guys have also answered light. Light replaces the electrons. PS2. PS2 is the reaction center. Darling, which process is related simultaneously with excitation of PS2? I repeat, which process in light reaction happens simultaneously as PS2 gets excited? Don't want to leave teaching here, but my time of sannyas has come. Whoa, hydrolysis. I should sit in a temple and just. Which process is related? Thank you, Priya. Laharika, thank you. This is non-cyclic photophosphorylation. Photolysis of water. Source of electron. Right here. One of the major differences between cyclic and non-cyclic. After the break, for the 5th time, I will repeat non-cyclic photophosphorylation. Thank you for keeping my heart intact. We broke ma'am's heart, I think. Yeah, you guys do that often, don't you? Huh? Is it clear? So what do you think is the answer? This is one of the probable questions. It's not like just to make this session a little tricky, I've put this question. This is a very commonly asked, frequently asked question. What do you think is the answer now? It's water. Naisha, and I claim to ease that out for people, so should work. Laharika, lots of love to you too. Vahida, how do you do? Cool people, good. Do we have more questions? No. We'll discuss rest of the things after the break. Cool. So what is the time right now? It's 8:14. We'll meet at 8:45. Good idea. I need this break. I'm not talking to you guys here. You broke my heart. I'm heartbroken. So I'm going to use the break to heal my broken heart. Really? PS2, yeah. PS2 has external source of electrons. Yeah. How could you do that? Oh. Dinner break. Whatever you want to do in the break. Do it. Okay, thank you. Take care. Bye-bye. I hope you are still in love with botany. Photosynthesis, sometimes we fall in love with topics, certain topics. Sometimes the teacher drives the subject. Whatever the reason is, the idea is to fall in love with learning. Once you don't study your syllabus as your syllabus, things happen. Alright people, how was the break? Some people didn't take the break. Did you take the break? I was away from the phone for the most part. Yeah, managed to fix some tea. Okay, good. Happy, healthy, doing good. Yeah, you should be happy. Being happy is important. Yeah, whatever you're doing is to be happy. So sometimes it will take effort, sometimes it will not take an effort. Give me a smile, everybody. I want smiley emoticons in the chat box before we start the second half of the session. The session should not, oh, it's 9 o'clock already. Shouldn't go beyond 11. Yeah, it will go till 11. We can sit together. We don't have anything better to do till we are NEET aspirants. We can sit with ma'am till 11 if ma'am is standing with us. 3 a.m. Oh, not all chapters are like morphology. That was one of the biggest chapters of your syllabus. Yeah, I've got messages, ma'am, we want a rerun of morphology, it seems. Oh, so many. Nikhil, the new section of NCERT that is added, it is already taken care of by me. You should explore the channel. There's a beautiful playlist that is made. Baba, share the session with your friends, family, neighbors, people you know, people you don't know. You know, where I was living earlier, last year I was at a different location. So there was a set medicine guy, yeah, that I and my family had. So one day I went to fetch some medicine for I think my father, and when I went to the shop, he was watching my video. It was a strategy video and gave me such a good laugh. Yeah, it was, of course, because he knew me. It was quite next to my house. It was a motivational video. I was talking about strategy for NEET 2022, I think, that time. 2022 or 2023, we held a webinar of increasing the learning curve. You know how your brain has a learning curve for every concept. So I think I'd spoken about it in one of the webinars and he was watching it. So that's why I say you don't know who might need the lecture, the motivation. You might think, oh, I shouldn't share with this person. What will this person think? This person is in this batch, studying from this teacher. They might not need it. You never know who needs the right guidance and right content. Isn't it? Oh. Yeah. Just share the session. Don't flatter me only with your words. Guys, don't say sorry, yaar. I don't like this word to be used so freely. I'll tell you one thing. Honesty with yourself is enough in this journey of competitive exam. You're not here to impress your teacher or impress somebody. I will keep having the batches here. I think it was just yesterday when I had this 2023 batch. Now you guys are 2024 batch. I'm already prepping up for 2025. Yeah, time is running so fast. It always runs very fast for a teacher who's teaching every year. Same happens for JEE. I speak to my JEE colleagues and friends, and they say, we just had the season of 2023, and the exam is right around the corner. So the thing is, we all could have the right intention, but sometimes we need to work on one particular weakness, Baba. So what is happening is sometimes attention deficit. And when we are not intentionally, attentively, attention is always 100%. There is no adulteration when it comes to attention. Only when you are 100% in the present moment, that particular event or experience will create that strong a memory in your otherwise it will be muddled. So the problem with syllabus of 11th and 12th is it doesn't give you the returns with half the love. And by love I don't mean any romanticism, I mean pure attention. So that is happening. You don't have to say sorry to me. I'm just telling you this happens. My experience of being a teacher and student. Okay, let's begin the class. Let's call everybody. Saucy, where are your friends? Where is your army here? You guys are so busy. Are you cooking the dinner? Are you getting grains from the field? Ma'am, I'm going to the field getting the wheat. Then I will crush it. I will make the flour. Then I will cook it. Is that happening? Yeah, everybody can give JE. Go whatever you want to do. Cool. Before I get lost into the chat box. See, chat box is distracting. That's why you will see me staying away, because I need to give pure intention to this class in order to give you all the concepts. Na? There are so many out of the book, in the book. Where is my pen? Why do you guys take my pen? Damn, I always do this here. Whenever I come after the break, and I have like 3 pens. Damn, what do I do now? Sorry guys, getting the pen here. Technology, thanks to Unacademy, a wonderful platform. But I'm very still adhering to this. Look at these are like, I think these notes must be 2015 batch that I taught. That's why they are in this condition. You should have very clean, nice looking notes. This is quite old. Ready to revise light reaction? Yeah? Ready, people? Eyes on the screen. Minds into the lecture. Because this is your last chance. No sorry after this. It's all thank you. It's all thank you after this. Yes, ma'am, we understood light reaction like never before. Now I am going to be a little pragmatic about it. I am going to, like I did earlier, club together light reaction and chemiosmosis, because that's the reality. Let's go to why whenever I am trying to teach there are questions. Okay, let's go to Mitchell. We solved this. This is the point where you broke my heart. Yeah? Okay. So let's heal the heart now. This is what I do in the first part of the evening. Yeah. pink one here is the thylakoid membrane. I drew it in green. It was the same, ditto. Okay. Now, Mitchell said that ATP formation, the process of ATP formation, whatever you have gathered, don't worry ma'am, I know, I don't know, mistake happened, you'll get it now. He said this is chemiosmosis. And he didn't do he didn't tell us some mind-boggling concept. We know osmosis is movement of solvent, ladies and gentlemen, from high concentration to low concentration across a semi-permeable membrane. Am I right or wrong? This is what osmosis is. Chemi, because here the movement is of chemical energy. What is that chemical energy? It is the positive charge this time. It is the proton this time. Agreed? One step at a time. No problem. Okay. So now he said, and that is what NCERT says, that in order for this process to happen, chemiosmosis, you will require just equate it with your knowledge of osmosis. Okay. You need a membrane, right? Here the membrane is the pink colored thylakoid membrane. Okay. So what are the requirements? Let's write it together. Requirements of chemiosmosis. Okay. The first one is membrane. Who is the membrane here? Who is the membrane here? It's the thylakoid membrane. Okay. Now, there has to be a disturbance. There has to be an imbalance. There has to be a gradient of concentration, isn't it? So, the second thing in this case, I need a proton gradient. It has to be between two areas, isn't it? So, here thylakoid membrane is separating lumen. We ascertained it. Open up your NCERTs, it will help you. There it is, lumen. What does NCERT say? High. That's why I love NCERT, for plant physiology at least. Yes. So, the proton gradient across a membrane is created, equated with osmosis, between lumen and stroma. We did it. We did it in the evening. This is the stroma. Since here we are talking about acidity or protons, I call it electrochemical potential gradient. Yes, also called as the proton motive force. No harm. Yes, because this proton gradient is going to motivate the chemiosmotic hypothesis. Till that gradient is not created, my tennis racket particles are not going to move an inch. Okay, ma'am. Then NCERT has been nice enough to mark that, see, protons or electrochemical potential is low in stroma and it is high here. One of the best diagrams of chemiosmosis. Scary also if you don't understand. The third thing that I need is a coupling factor. Or rather, the only factor or the protein which could allow the protons to pass through this barrier, this membrane. because rest of the membrane is impermeable to protons. Okay, so this is your third requirement, ladies and gentlemen. This is the first requirement. Okay, this is your second requirement, and this is your, we drew it. In fact, I became the lumen, you were the stroma. This is what is coupling factor, or the F0, F1 particle, Fernandez-Moran particle, oxysomes, whatever you fancy. Okay, this F1 has, it is marked in NCERT. I don't want to clutter the diagram. ATP synthase enzyme. And I taught you that protons are going to pass through the F0 or the foot of the coupling factor, cause certain disturbance, movement. If you have visited outside India, it's not very common in India. You have those, now it's common in India, it's right next to my house. There are revolving doors. Okay. So now this revolves and causes this. There we go. ATP is formed towards stroma, and that's where it is intended to be made, because the next set of reaction, like I said, oh God, broken record. Like I said, dark reaction takes place in stroma. Enzymes of dark reaction are placed in stroma. Now there's one more thing I need, and my favorite from the evening, that is the proton pump, or what NCERT says, proton carrier. Okay, so hydrogen pump, or seemingly the carrier. I use the word seemingly quite intentionally. Okay, so I taught you in the evening in Z scheme that this guy here, you see, he becomes in his own innocence the sort of a pump here. Okay, so that's all. This is the fourth requirement. Da 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 da. You got it. Now nobody can fail you in light reaction if you've understood with me the four requirements. Simple. Baba, simple. I need high acidity in lumen. And I need a deficit in stroma. Simple. Do it as you wish. So this is snatching away the protons from the stroma and pulling here. If I talk about non-cyclic, then oxidation of water is also happening in the lumen. What to do? Protons are made, pulling up in the lumen, more acidity. And this guy, stroma, is becoming deficient also, because NADPH that you get here, reduction of NADP plus, yeah, you got the electrons from all of this light reaction, but protons are taken up from stroma to give me NADPH. Minus, plus, plus, haha, acidic, alkaline, 2 to 3, 7 to 8, pH. Okay. Now, just because you guys want a repetition and seeking a repetition, guys, 5th time, yaar, come on, have some mercy. PS2 gets excited at 680 nanometer, loses an electron. See, NCERT hasn't shown it clearly. Loses electron, 2 electrons. They go to pheophytin, who is the primary acceptor, not mentioned here. You will add it. Goes to plastoquinone. At the same time, plastoquinone thinks that I can take positive charge from the stroma, and that's why NCERT shows you, and become absolutely reduced. It does get reduced for some time. PQH2, plastoquinol. But at the same time, Naisha, this is the mistake that you did. Simultaneously, photolysis of water happens. One of the very defining feature of differentiating feature between non-cyclic and cyclic photophosphorylation. At this time, this proton comes in here, and cytochrome B6F, see it is transmembrane. Transmembrane means it traverses the membrane. Yes, it's a phospholipid membrane, nothing else. That's why we called it semi-permeable also. Cytochrome B6F takes the electron, gives it downhill. Movement of electron is downhill. Redox potential is increasing. To plastocyanin. Plastocyanin gives the electron to PS1. PS1 gets excited at 700 nanometer. 700 nanometer gives it to, NCERT hasn't shown iron sulfur protein, you will add it. Gives it to ferrodoxin. Ferrodoxin, see, I told you FNR is located in the stroma. In the stroma, I use these protons, I take up protons from the stroma and use these two electrons which started their path from PS2, which left home. Home was PS2, they are not getting back. Hence non-cyclic photophosphorylation. One of the differentiating features. Yes, and we get NADPH. Here I have already told you, this pooling, this guy is bringing a lot of protons, pumping protons into the lumen. Photolysis of water is giving protons into the lumen. This disbalance will activate and this will move and ATP will be formed. The ball is not here now. That was the proton in the evening. The ball is the proton. Fuel. Since you guys don't give enough fuel to the fire, I have to drink tea like 5 times a day. Okay, people. Now, time for 2023 question and the chat box. Simultaneously, keep my heart intact. Shahrukh Ahmed, good to have you. Rehana, good to have you. Bhavna, hi Bhavna, what's up? कुछ तो Oh, seems like an easy question. Dharanya, I always, your name always makes me happy. Mayuk, why did you take so much of time in solving this question? Didn't expect this from you. Bhavna, I am, what do you think? I am blessed. This God's grace that I am teaching such a lovely chapter. So all good. Okay. Which of the following combinations is required for chemiosmosis? See, if you thought ma'am is telling you some foreign extra information, it's a recent 2023 question. Now, people like Sausi will say, ma'am, it came in 2023 only, it is not going to repeat, they are not going to copy paste the question. Point number 1, it has happened in the past. Secondly, I can show you, before NEET exam, I'll show you the proof of this. Secondly, it is not the question itself, the wording of the question, the concept gets repeated as it is. So here the concept is requirement of chemiosmotic hypothesis. Can we agree to that? There is no solution. Oh, I had to solve this for you. It's your exam. Proton pump, electron gradient, go away. Membrane, proton pump, proton gradient, ATP synthase. Wow, we just wrote it. Membrane, proton pump, proton gradient, NADP synthase. No. Proton pump. Okay. Good to go. Clear? We took a break. Another question. 2023. I did not make up the question. While you answer, I just declutter my space. Answers please. My eyes are on the screen. Come on. Oh God. No answers? What if one day I lose all the patience here? I don't know from where I get it anyway. To start with. Answers in the chat box, people. This is 2023. Oh, okay. Oh. Sorry guys. Ma'am didn't move. Krutika has given the answer. Only Krutika has given the answer. Laharika has given the answer. Pravalika, bete, try Google. Try Google. Google is better. Identify the correct statements here regarding chemiosmotic hypothesis. Bless you with this question. If you were not listening, I have a feeling it will come. Splitting a water molecule takes place on the inner side of the membrane. Yes, no? What is inner side of the membrane, Baba? It is lumen, na? Evening, entire evening. This is inner side. This is outer surface. This is inner surface. Yes, no, maybe. Protons accumulate within the lumen of thylakoids. I've been singing this song since evening. Yeah, this is also correct. You will not see in such questions when he has given you multi-statements and he's asking to pick out correct and incorrect. You first pick out. Then you look at the choices. Otherwise, they will confuse you. The primary acceptor of electron transfers the electron to an electron carrier. Spoke about this. Pheophytin to plastoquinone. Plastoquinone is not called as an electron carrier. It is seemingly a hydrogen carrier. NADP reductase enzyme is located on the stroma side of the membrane. FNR. Protons increase in number in stroma. Bad. I got A, B and D. I got A, B and D. Thank you very much. Thank you very much, ma'am. Good? Yes? Let's go. Dark reaction. Ready? Everybody? Phasing you guys out is important here. It's called as the, what did we say in the early part of the evening? We said it is biosynthetic phase. Because synthesis of things will happen in a living cell, that is chloroplast. What is the site, exact site of dark reaction? It is the stroma of the chloroplast. It is actually the anabolism in action. So I would need enzymes. Now dark reaction is not the right term. We should call it light independent reaction. It doesn't mean that it is happening in the night. It is very much happening in the day. Light independent reaction dependent on assimilatory power. Assimilatory power of light reaction. What is assimilatory power of light reaction? Quickly. Assimilatory power, the power that can help us to synthesize ATP and NADPH. We got it since evening. Yes, no? This is the first point here. Cool? Now, the enzymes, it's an enzyme driven, can I say endergonic, anabolic process? This means that whatever affects the enzyme kinetics will affect this reaction as well. Yes? Now, this is also called as, yeah, you can take down these points, C3 cycle or Kelvin cycle. Well, why is it called C3 cycle? Anybody who knows why it is called C3 cycle? Because the first stable product is a 3-carbon compound. Name of the compound, people? Lovingly called PGA. We'll talk about the full form later. We're not worried. We are just understanding the introduction of the process. Happy? Healthy? No problem? Okay. Then, why is it called Kelvin cycle? Kelvin cycle. Nah, let's write it in detail. Why is it called as Kelvin cycle? Ma'am, this is easy. Kelvin and Benson. Actually, there are many people involved. There is Warburg involved. It's also called as Blackman's reaction. There are so many people involved, but the problem is the one who gets you the final equation of the chemical reaction, who wraps up all of it, gets the credit. So, Kelvin and Benson discovered Kelvin cycle because he discovered, I am forgetting the year here, and got a Nobel Prize. He discovered by experimenting on, in my time this question used to come here, by experimenting on chlorella, it's a unicellular green algae, and Skindesmus. By using C14, this question I've seen around 2014 or somewhere, 15, which is a heavy radioactive isotope of carbon. Yes, this is important. If you don't want to remember the organisms, it's okay. But you should know that we got to know that carbon dioxide is reduced to glucose and we could trace the path. This happened around World War II. I think NCERT introduction says it. So, World War II, we had so many radioactive elements in the air. This guy studied the path of carbon dioxide. Like, what does carbon dioxide go through? For a long time, we could not even trace the acceptor molecule, the primary acceptor in Kelvin cycle. Everybody, we don't know. We know this came earlier. Do you know that? When C3 cycle was discovered, the product we knew that it's a 3-carbon product. And we know that we are getting 1 carbon dioxide from the atmosphere. So, should the acceptor of carbon dioxide be a 2-carbon compound? Finally, Kelvin could trace the path by using a heavy radioisotope carbon 14. Yes. Now, This process has 3 stages here. Not steps, stages. It's a long multi-step process. I still remember getting so affected by, because we were taught to do all the steps. Yeah. So you guys have it quite in short. So there are 3 important stages. Very simple, yeah. Carboxylation, that is actually fixing the carbon dioxide. Without carbon dioxide, nothing can happen. Then reducing, reduction, and finally, if I am calling it a cycle and I want it to continue, I need the acceptor molecule again into the picture. Yes? So regeneration. Happy? Can we do that? This is shown, this much is shown in NCERT also. Now, any photosynthesizing plant, be it your cyanobacteria, be it your banyan tree, mango tree, C3 cycle is called as the universal cycle. Okay? So it is seen in universal simply means not happening in us, but seen in all photosynthetic plants. Can we do that together? Yeah, you will understand why we are saying that. Because certain plants have come up with alternative methods, variants, okay, to ward off, to adapt to evil processes like photorespiration. So a plant can have auxiliary processes to act smart, but C3 cycle is an essentiality. This much is clear. Now let's get to the cycle. Before we get on to the NCERT cycle, what do you think? We'll draw our own cycle like we did for chemiosmotic and light reaction. Can we do that, everybody, since you guys are so writing with me? We are blessed because of NCERT. Tell me in the chat box who's not a part of Endgame 2.0 batch. It started today. Rihanna, I hope you love it here as well. What wisdom. I was just telling somebody, usually I don't take a vacation more than twice a year. It's going to happen very soon. I need it. Okay, people. So let's start the cycle. What do you think? Let's start the cycle. The primary acceptor, we don't need to use the word primary here. The acceptor of carbon dioxide is RUBP. What is RUBP? Pentose is 5 carbon compound, right? Ribulose, how do you write it? I don't want to go wrong. Ribulose 1,5 bisphosphate. Yeah, the nomenclature you study in your chemistry. So this simply means the idea that I get is on first and fifth carbon, it's a 5 carbon compound, and on first and fifth carbon, I have phosphate groups. Good, very good. If it is a 5 carbon compound, let's keep calculating the number of carbons. That's very important. The question that will be asked, it is the primary acceptor of carbon dioxide. Okay, ma'am. Now this guy is going to do the honors, combine with atmospheric carbon. Of course, do you call it carbonic acid? H2CO3, do you call it carbonic acid? Okay. So this is 5 plus 1, 6 carbons. But you just said, ma'am, first product, stable product, we named it C3 cycle, that is serious, we call it PGA. Okay. So this is the first stable. Why do we call stable? Have you thought about it? Because there are intermediate products also formed. So the first stable product that is formed is rather 3-PGA. That simply means phosphate group at the third carbon. You would know better. Yeah. So it is 3-phosphoglyceric acid. It's an organic acid. The chemistry part you guys will have to rather guide me. Now this is a 3 carbon compound here. Okay. So this is a 3 carbon compound and 5 plus 1 is 6. So what do? We make 2 molecules. 2 molecules of 3-phosphoglyceric acid. It's an organic acid. Now this carboxylation, what do I call this, ma'am? I call it carboxylation. Yes, very easy to understand, no problem at all. This requires a very crucial enzyme called as the Rubisco enzyme. Now this enzyme is rather interesting. What is so interesting about him? Do you see that I have C and O together? So boys and girls, Rubisco enzyme is the most abundant, thankfully, most abundant enzyme in the biological world, and it has both carboxylase, that is, it has the ability to fix carbon dioxide as well as oxygen. It is friends to both carboxylase and oxygenase activity. Now boys and girls, ma'am, does that mean it is combining with both? And here I am doing carboxylation. What do I do? What's happening? At the normal concentration of the atmosphere, there is a ratio in which carbon dioxide and oxygen are present. For example, carbon dioxide is present at the percentage of 0.003%. Very less. This guy has more affinity for carbon dioxide. Okay? Ma'am, so much of pollution where you live in a metro city, you live near an industry, ma'am. So carbon dioxide is increasing. What happens then? Okay, yeah, or oxygen. What if I give more oxygen? I release an oxygen cylinder. What happens then? Yeah, so here we are not really always talking about the atmospheric concentration. It has to be near the leaf surface. It has to be close to the leaf surface. If that concentration changes, things will happen. We'll talk about it. So write it that it has more affinity. It is better friends with, more affinity to carbon dioxide. But there is a but to that. You maintain the normal ratio that was intended, then I'll be fixing it. Cool, people? Now, what NCERT says, this phosphoglyceric acid changes into NCERT says, blinds us by saying triose. Triose simply means a 3-carbon compound, isn't it? Yeah, let's write the full form of this Rubisco just for clarity. Did we write it? Rubisco is nothing but RUBP, ribulose 1,5-bisphosphate, carboxylase and oxygenase. Happy? Well fed? Ma'am, feed us everything. You should make running notes. Triose phosphate, spoon feeding. Simply means that it is 3-carbon compound. Now, if you have studied glycolysis, who is the star compound in glycolysis? I call it the star compound. It is 3-PGAL. Who does everything. If you haven't, it's okay. Next chapter is respiration. So what we are going to do is, I am short of space. 3-PGAL is 3-phosphoglyceraldehyde. You want to make fats? He's the guy. You want to make sugar? He's the guy. This step is also called as reduction. Papa, your chemistry teaches you aldehyde is changing into, glyceric acid is changing into aldehyde. And you know that there will be reducing power required. Isn't it? So, phosphoglyceric acid is changing into 3-phosphoglyceraldehyde. It is a 3-carbon compound, no problem. It is a 3-carbon compound, no problem. And here also I will have to make 2 molecules to balance out the carbon. Let's call it reduction, or for the sake of everybody, glycolytic reversal. If you know, very good. If you don't know, still very good. Now, NCERT says this changes into what I am seeking, C6H12O6 or the glucose. Okay, ma'am. Seems doable because 6 carbon, pretty world. Simple life. Yes? Now what is happening here? If I am wrong, let me know. This PGA will change into 1,3-bisphosphoglyceric acid. Glyceric acid. One molecule of PGA, when it changes into 1,3-bisphosphoglyceric acid, it's quite clear. There was phosphate group at the 3rd position. Now I have to add at the 1st position. I will have to use 1 ATP. Am I right or not? Now what is happening? I am going to change this 1,3 bis phosphoglyceric acid, I am writing in short, 2 aldehyde. So I will use one molecule of the reducing power NADPH, and you made these reducing power in the light reaction in stroma. You have them. You used 1 ATP for one molecule, 1 ATP and 1 NADPH for one molecule. Why am I repeating this again and again? Because the AC is, yeah. Because they sort of trap you in these questions. How much, what is the expenditure of energy for one molecule of PGA or 6 molecules of PGA? You have to be very careful. This topic always traps people just in terms of language of the question. It's not the concept. It's very easy. Concept is easy. So, when I use NADPH, this changes into 3-phosphoglyceraldehyde and I get this and I get phosphoric acid. Okay, ma'am, if you say so. So, boys and girls, in this reduction process, that is how NCERT is showing the expenditure of, because there are 2 molecules in action. So, I do 2 ATP, I do 2 NADPH. Can I do that? Comfortable? For one, now that's your chemistry. I don't need to really tell you you don't have to do the multi-steps of the reaction, but we just saw here, right? This is the expenditure for reducing one molecule of PGA. Okay, don't forget that. It will give you more clarity. Okay, fine. Now the third step ma'am told us is regeneration. Let's regenerate this molecule, RUBP, and comfortably call it regeneration. Happy world. The problem is when this PGAL is regenerating, yes, it is using 1 ATP. Ma'am, what is the problem here? What is the problem? We have enough energy, we made enough energy in light reaction. Okay, if you say so. But my problem is something else. Eyes on the screen. You had 6 carbons here. You are saying I am using all the 6 carbon atoms to make one glucose molecule. You did that, right here you did that. You are creating a null. You are null here at the level of PGAL. My question is, first of all, in this biochemical reaction, in the body of the plant, you cannot create a null. Secondly, you said carbon dioxide will be fixed to glucose. So, at the cost of one molecule of carbon dioxide, you are claiming to give me 6 carbon atoms in one molecule of glucose. And you are creating a null here and then claiming that you are regenerating a 5 carbon compound. Come on, not possible. Okay. So, the NCERT cycle that is visible is not the actuality of the situation. We study it as a single cycle to understand the steps, and that's about it. And then NCERT says 6 cycles, 6 Kelvin cycles should run to form one glucose molecule. It's not the way it is stated. It's not like, hey, one cycle, then second carbon comes, then third carbon, and 6 cycles will run. No, this cycle cannot run, Baba. Look at the cycle. This cycle, once I reach here, it will be a null. It will be 0. How will I regenerate? And that is one of the steps. So NCERT says 6 cycles to make you understand, you and I understand, but 6 molecules will combine into 6 RUBP at once. So what NCERT is trying to say is, Baba, whatever you've studied with me, understood with me, it is happening 6 times, tata bye bye. Once again, 6 molecules from the atmosphere of carbon dioxide will stand in front of RUBP, and 6 RUBPs will fix 6 carbon dioxides to make 1 molecule of glucose. So this is how he will trap you in the language of the question. For 1, if he says what is the energy expenditure for 1 molecule of carbon dioxide fixed by RUBP, yes, affirmatively, I have 3 ATP and 2 NADPH. Okay. Yeah, you want to write the energy expenditure? Let's write the energy expenditure also. For 1 molecule of carbon dioxide, I require 3 ATP and 2 NADPH. But that's not the truth. What will I do with 1 molecule? So 6 into 6 into with me everybody, into 6. Yes, into 6. If you do the 6, things will make sense to you. Into 6. Good. Now let's do the carbon count. 6 molecules of carbon dioxide combine with 5 into 6, 30. A total of 36. I get a 36 carbon count. Come here. I was already making 6 PGA, 6 carbons here. 1 PGA is 3 carbon. I was making 6 carbons. I am just counting the carbon. 6 into 6, 36, balanced. I reduce this guy into PGAL. I was already making 6 carbons. Now I am making 36 carbons, balanced. Now what will happen? How do I make the glucose? So actually, I will take out 2 molecules. 2 molecules of 3 PGAL. I will keep them on the side. And 2 molecules of 3 PGAL simply means 6 carbons. There I go. I can make 1 molecule of glucose. I am going to write it again, don't worry. Let's write it again. So ultimately what's happening, since that page got cluttered, this is very important to understand here. That 2 molecules of, you want to call it triose phosphate, okay. 2 molecules of 3-phosphoglyceraldehyde, which is a 3 carbon compound, equals to 6 carbons, gives you 1 molecule of C6H12O6 glucose, which is again 6 carbons. How many did I make? How many did I make? I made 12 molecules of 3 PGAL just now. So this means I am left with 10 molecules even after forming glucose. Yes. So let's write here. So those 10 molecules of 3 PGAL, you tell me the carbon count of 10 molecules of 3 PGAL quickly in the chat box. If I am a 3 carbon compound, use the complicated, get your calculators if you wish to. 3 carbon compound, 10 molecules, 30. How many do I need here? 30. I am going to erase this, causing confusion. 5 into 6, 30. I get my RUBP and this seems genuine. I don't really have to ask. I can so see the faces right now. Where am I sitting? Why did I take biology? I could have easily taken maths. Why? I don't want to clear NEET exam. It's okay. This is the simplest cycle you will see. Okay, it's very difficult. We'll make it simple. I'll repeat it. Baba, it's nothing. If you study patiently, it's nothing. Sort of is also okay. Sort of understood, ma'am, is also okay. Let me see what you guys are doing with no care in the world. You know, this is the era where NMC should allow teachers to sit for the exam on your behalf. Huh? Sausi has spoken the truth. Wow, what serious students. Sausi, I don't have the choice here. That's all. There's nothing what you're saying. What are you hearing for the first time? I don't use my patriotism in explaining Kelvin cycle. Come on. Done? Not understood. Naisha, don't have to go under the table here. It's okay. You're not supposed to understand everything in the first go. Remove that assumption. I should know everything. I should have all the answers. I should understand everything in one go if I am attending a class. Ma'am, when did you give your first class as a teacher? How is that important? You tell me. First you, see, I prove everything I teach you, every line, every concept with an evidence. Bacha, this concept holds truth because this is the case, this is happening. You tell me, how is it important? Do you want a repetition of C3 cycle, dark reaction? Would you guys want a repetition? Yeah, I have to buy new nail paints here. But thanks. I didn't say that. Come on, I never, did I say that? I didn't study this chapter in 7th class. I could never say that. I was clueless in 7th standard. Yeah, I didn't. I didn't say that. Bap, no. Okay, come on. I was more interested in history in 7th. I categorically remember. My favorite class used to be history. If I wasn't doing this, I would be doing something with history. Okay, fine. Calm down. I did not. Cool, yeah. We'll make an attempt to make you understand. Repeat this in the NCERT version. Quite clear, quite clear. This is what your NCERT says. And then we'll solve MCQs also. Good idea? Ribulose 1,5-bisphosphate. अच्छा ऐसा हमको परेशान. This is the ribulose 1,5-bisphosphate. Let's fill it up. Let's fill up the diagram with the information that we have. So this is a 5-carbon. It's a 5-carbon compound. It is also popular as the primary. Let's write the short form. Also popular as the primary compound. Okay. Combines with atmospheric carbon dioxide. Yes. Carboxylation happens. It is also called as the most crucial step, because the reaction won't go further if I don't have carbon dioxide. Listen to me patiently. Last chance. Most crucial step. I make a 3-carbon compound. Third carbon has the phosphate group, 3-phosphoglyceric acid or 3-phosphoglycerate. Now I reduce this organic acid, reduction, the second step. Yes, this will be the energy consuming step. Energy consuming step. When we said endergonic, this is where you get specific with endergonic. ATP, I told you, I split the reaction. 3-phosphoglyceric acid to 1,3-bisphosphoglyceric acid, I use ATP. Per molecule, 1 ATP, very simple. 1,3-bisphosphoglyceric acid gets reduced to 3-phosphoglyceraldehyde. Where is it? There. Using NADPH. Since I have two molecules, I do into 2. Okay. And after triose phosphate, 3-PGAL, claims NCERT that it forms sucrose and starch, not also glucose. It goes to the next level. Glucose is made, it is stored as starch. Then triose phosphate regenerates with the help of 1 ATP and forms ribulose 1,5-bisphosphate. Ha ha. But we know the reality. Yeah. It didn't even mention, NCERT is cute. It didn't even mention RUBP here. Sorry, Rubisco here. Cool. Now people, food for thought. If the energy expenditure of 1 carbon dioxide to fix 1 carbon dioxide, we said is 3 ATP and 2 NADPH. My question to you is simple as always. What will be the energy expenditure? Listen to the question carefully. Energy expenditure to form, I didn't use the word fix, to form 1 molecule of glucose. There you go. Yeah, mom, get ready to get your heart broken. Gosh, that's it? Only 18 ATP? That's it? So I get 3 into 6. The language was important. This can also be framed as energy required to fix, but here it won't be one molecule. If I want to frame on the same line, I would say to fix 6 molecules of 6 molecules of CO2, because I know 6 molecules of CO2 are required to form 1 molecule of, what disheveled state, 1 molecule of glucose. So 18 ATP and 12 NADPH. Okay, ma'am. So now if he goes to the next level and says which of the following is the correct equation for which of the following equation, I am just forming a question right here, represents correctly the formation of 1 molecule of glucose. Yeah, you understood my motion? How will you write that equation? Let's write it together. Well, if the question has equation for 1 molecule of glucose, see, the equation will differ according to what the examiner wants. Is he saying pinpoint or choose the correct equation to fix 1 carbon dioxide? It's different. Here I want 1 molecule of glucose here. So 6 molecules of ribulose 1,5-bisphosphate will combine with 6 molecules of carbon dioxide, will use 18 ATP, will use 12 NADPH, you guys told me on your own. Okay, and I am going vertical. If you are writing the equation with me, go horizontal. I will use various enzymes. 6 RUBP will be regenerated, ladies and gentlemen. That is the final step here. Don't forget to regenerate this guy, because I want the cycle to continue. I can't just form 1 molecule and go back home. Plus, this is fixed, gone. 18, I will get ADP plus inorganic phosphate. Then again the cycle will continue. Plus, I will get 12 NADP plus. Plus, I will get the main product. The main product is, I am seeking 1 molecule of glucose. He is the guy. Main product. Acha, oh, somebody is showing their knowledge. Ah, good, good. You know, when you write answers in the chat box, it cements the concept in your head as well. Good. Good. What happened? Everything is okay. Zen, what happened? Why are you spamming the chat box? Oh. People are also deleting their messages. Sausi, did it help? People, did you find it easier that second time? Okay, Zen. Very good. Cool. Let's go further. There is a question from NEET 2023. What do you do? Ma'am is giving so many questions only. Answers in the chat box. Come on. No, you need to revise here. I am not going to believe you. Ma'am, I know Kelvin cycle quite perfectly now. C3 cycle is done. Light reaction is done. This is one chapter. You might want to, you might have to, you should watch this lecture at an increased speed and revise the concept, opening up your NCERT. Everybody is sure? People are so excited, they are answering multiple times. How many ATP and NADPH2 are required for synthesis? See? But he didn't confuse, right? The choices are very non-tricky. Anybody could do it. He would have made it problematic if he gave a choice. He should have 3 ATP and 2 NADPH. What do you think? This kind of paper I am waiting for. He's been student friendly. So we know this is the case. Easy. But let's go. One more question. 2022. Everybody. Oh, nice. If you will spam my chat box, I'll ignore you at least for 10 classes. HSP sir is in the class. Oh, my chat box has become so special. My favorite teacher. Thank you so much, sir, for gracing the chat box. Oh, aren't you guys lucky? Yeah? So there is a lot of chemistry happening in photosynthesis, Baba. It's all a lot of organic chemistry. Maybe one day if I get to teach with sir in person, perhaps when sir will come down to Bangalore, we will study photosynthesis in sir's presence. What do you think? Do you want HSP sir to teach photosynthesis one day? Huh? Count all the carbons, tell you all the steps of Kelvin cycle? Yeah? Yes, sir. And hard work always pays, yaar. Sometimes it becomes late, but it pays. Okay. Yeah, sir will make photosynthesis magical. We'll study all the enzymes, we'll study about all the steps of Kelvin cycle, the electron loss, the proton gradients, everything from sir. Huh? Thank you so much, sir. Lovely to have you. Magic spells of photosynthesis. Yes, with the good teachers, the subject becomes a magic spell, and that's what you need. You need a spell of all the important concepts. Isn't it? Awesome. Chalo, let's go further. Thank you so much, sir. So now let's see this variant of the question. See, I told you a while ago, he will do something with the language of the question here. The concept is going to remain the same. In the previous question, he spoke about one molecule of glucose. Now, exactly what I told you, he did that. When one CO2 molecule is fixed as one molecule of triose phosphate, very tricky. It can be tricky if you haven't seen the cycle. I have one molecule of triose phosphate, not two molecules of PGAL. Which of the following photochemically made? He is actually explaining that you made ATP and NADPH in light reaction. High energy chemical intermediates are used in the reduction phase. What a nice way to ask the question. So I told you, for one molecule of PGA, ladies and gentlemen, let's go back to the cycle. You would need one ATP, one NADPH. I told you the reaction also. Yeah, this is what I was saying we'll study from sir. Isn't it? I showed you the reaction to my own capability or little knowledge. 3 PGA, one molecule. We'll use one ATP. Oh, and it will change into 1,3-bis phosphoglyceric acid. Cool. 1,3-bis phosphoglyceric acid will use one NADPH to get reduced with the dehydrogenase enzyme. With the dehydrogenase enzyme to change into 3-phosphoglyceraldehyde. Here I think the enzyme will be kinase. Yes, it will be 3-phosphoglyceric acid Kinase. You don't have to learn the enzymes. Just saying. Just to create familiarity because you guys are good with chemistry. Okay. So what do you think? The answer will be, if you know this, then the question is very easy. But if you have just mugged up the NCERT cycle, not happening. 2022, can't say this enough, best paper of botany at least. We'll discuss NEET 2022 paper before you go into the exam, don't worry. Alright, let's go further. Ready for photorespiration, people? Another concept. Is everybody ready? If you're ready, give me a thumbs up in the chat box. How about that? Phosphoglycerokinase, Atharv Pratap Singh is saying. Thank you. That is the enzyme. Sausi. Okay. Photorespiration, what happens? I change sequence for a reason. We are going to break this term, alright, and phase you guys out. Respiration simply means, if I talk about the absolute basics, it is evolution of carbon dioxide. And utilization, use of oxygen. This is respiration. I use oxygen. I form carbon dioxide. You inhale oxygen, you take out. This is mechanical breathing. But at the level of cellular respiration also, I use, listen to me carefully, we are doing basics, 1, 2, 3. And you will not get it again. You will not get it if you read the textbook also. Okay. So, photorespiration means at the cellular level also I use oxygen, I give out carbon dioxide, but I form a lot of energy, 38 ATP. Agreed? This means I should form energy. I should make ATP. Okay. Now, ladies and gentlemen, to my surprise, these things happen in the presence of light. In presence of light. Boys and girls, once again, eyes on the screen. No need to look at me. In the presence of light, I evolve carbon dioxide and I take up oxygen. My goodness, you promised me that in the presence of light, you will remove this foul carbon dioxide and give me oxygen. You're doing the opposite. That's not all. I end up using ATP. This evil process happening in the plants who are doing C3 cycle that you just studied is called as photorespiration. When does it happen? Why does it happen? Well, the culprit is this enzyme has a common site, the active site for fixing carbon dioxide and fixing oxygen. But our atmospheric concentration is such, the ratio of carbon dioxide and oxygen is such that he has, like I said, more affinity for carbon dioxide. But if oxygen concentration increases, then this guy, Rubisco, seeks greater affinity for oxygen. He's not doing it all the time. If you disturb this ratio, okay, beyond 3 to 4% of oxygen, this will become active, more affinity. And then instead of fixing carbon dioxide, he's getting oxidized. Who is getting oxidized? RuBP is getting oxidized. In what conditions it can happen? Let me also tell you that usually in plants, especially which live in high temperature is akin to tropical areas. What are tropical areas? Located near the equator. Tropical areas. Amazon rainforest, for example. Sun rays are at 90 degree. Very light, very high light intensity. Light also comes with temperature, na baba? So, high light intensity ultimately disturbs this ratio. So, those C3 plants which live in these conditions never realize the full potential of Rubisco. This means that every C3 plant is undergoing some amount of photorespiration. It's not that zero oxygen will combine. If the rate is very low, if photorespiration is very low, it's okay, let it be. Is that clear? So, but if there is a considerable rise, let's say you increase the oxygen concentration to 21%, gone for a 6, your RuBP will get oxidized. And when it gets oxidized, my goodness, 3 organelles become active. Okay, 3 organelles in the same order. This is the new NCERT has, there was some account of photorespiration in the old NCERT. Okay, the new NCERT talks very cryptically. So I am making it clear. This is a previous year question. What organelles in which order? Very frequently asked question. The first one, of course, is going to be the chloroplast, no taking away, because this is present in chloroplast. Rubisco, the culprit, is present in the chloroplast. But the problem is, after this site is in action and oxygen comes in action, something happens, which I am going to tell you. We are going to go a little bit outside NCERT and do that. Peroxisomes, if you haven't heard about them in the chapter of cell, hydrogen peroxide metabolism. Think it's a multi-step pathway. Don't worry, we are not going to get into the details of it. But imagine hydrogen peroxide is formed as a result of this. How fatal could it be? A cell will never accumulate H2O2. So they come into action, and then mitochondria comes into action. The powerhouse of the cell. Ma'am, when this happens, when I see high temperature, high light intensity, oh God, bad day, Rubisco has become now RuBP oxygenase. Carboxylase is shut off, that site is taken up. Does that mean C3 cycle will not happen? What did I tell you in the first part of the evening pre-break? C3 cycle is a universal cycle, come what may, C3 will happen. C3 cycle is such a strong cycle, and the way plant has kept it evolved to keep it going is fabulous. Okay, so what happens on a bad day in tropical areas, high light intensity and high temperature, is something called as photorespiration. Is that very, very clear? Now, I am going to, if you don't want to do the explanation of photorespiration, it's okay. But these are previous year questions. If your paper is like 2022, these questions can come. If I said that chloroplast is involved, what happens in chloroplast? So we are not going to do all the steps. We are not going to do all the steps, but we'll do the major ones which have been asked in a question. What happens in peroxisomes? So that you are not uninformed. What do you think? Good idea? No, ma'am, I don't want to do anything. Chloroplast हो गया, peroxy हो गया. अब मुझको मांगता है mitochondria. Mitochondria, ladies and gentlemen. They'll have plasmodesmata in between them, don't worry. Huh? Plasmodesmata. What are plasmodesmata? Oh, that was fine. I don't mind that. What are plasmodesmata? No clue? Wrong clue? Right clue? Don't know? Whatever it is, state it out. State it out. Oh, whenever I'm in the class, I'll get all the. Basically, it is a junk. Samriddhi, how do you do? Good to have you. Mitochondria. Ma'am, please tell me, is secondary tissue in our syllabus or not? The virtuous Quran. My dearest, where are you from? Where are you watching us? Could you tell your location? It's okay. Secondary tissue is in your syllabus, definitely, very much. But secondary growth is not in new NCERT. Personally, I would say read secondary growth and go. You should not miss secondary growth. Because even the families are not there in new NCERT. The new families mentioned in NMC notice are not in NCERT, but you got to do them. Acha, sorry ma'am. Ma'am, I'm Samriddhi. Samriddhi, why are you late? Cool people, let's go. Now, RUBP expecting to combine with oxygen breaks down into 3 PGA plus, I am not writing the full form of this one, but this new thing, new compound, phosphoglycolate. This you have to learn. This is very much an NCERT. Okay. So I will always balance the carbon. This is a 5 carbon. Yes, ma'am. This is a 3 carbon. Yes, ma'am. This is a 2 carbon. Phosphoglycolate. This phosphoglycolate will in the chloroplast get dephosphorylated and change into glycolate. Now, ladies and gentlemen, this cycle is also called by some authors, not very popular, as the C2 cycle. I personally feel we should. Why not? This 2 carbon compound, the plant is not going to be okay with it. It's not going to take it lying down. You formed some foreign compound within my chloroplast, I am going to live with it. No, plant is going to focus on the metabolism of this one. Dephosphorylation, I change it into the glycolate, okay, and through the plasmodesmatal connection, I transport it into the peroxisome. Glycolate, I am just telling you some of it, gets oxidized into glyoxylate, and then amination happens and it changes into glycine. So this is the question that he sometimes goes for. Amino acid glycine. Yeah, tell me something about glycine. Been a while. Tell me whatever you know from chemistry. What do you say? Tell me something about glycine. What do you want me to repeat? Huh? Tell me something about glycine, people. So he will ask that which organelle will give you the amino acid glycine. This glycine, through the plasmodesmatal connection, gets transported to mitochondria. Now here two glycine will combine together. Clear? So glycine plus glycine is 2 and 2, 4 carbons. It's a game of carbon, right? And I form an amino acid called as serine. This is the question, previous years. Where is serine formed? Tell me something about serine. Come on, you guys are not telling me anything about it. Now, think about it. Serine is a 3-carbon compound. It's a 3-carbon compound. Right or wrong? So what happened here? Eyes on the screen. Eyes on the screen. Just proving it to you. Why did I take this pain here? Why did I take this pain? To prove it to you why photorespiration is a wasteful process. Baba, here 4,3 decarboxylation happens. Mitochondria, carbon dioxide goes out. I was supposed to fix carbon dioxide. I am losing carbon dioxide. I am losing carbon dioxide. Now peroxisome, when it does all of this, no, it is not as simple as it looks. I am just telling you some part of the steps to keep you safe for a rainy day. Oxygen is evolved. Okay. Now this serine, through plasmodesmatal connections, goes to peroxisome. Okay. And serine changes to glycerate. Yes, I can do that, ma'am. Glyceric acid I can form. That is also a 3-carbon compound. Yes, ma'am. You are right. You are right. Okay. That happens. Ammonia is also released somewhere. That's okay. People, this glycerate now, if you thought this carbon dioxide is going to enter the Kelvin cycle, it's not a good day. It goes outside the mitochondria. This PGA, like I said, however bad the day is, plant will perform C3 cycle. C3 cycle. Ma'am, then what is the problem? I'll tell you the problem. I'll tell you the problem. This glycerate gets transported through the plasmodesmatal connections. Okay. This glycerate will now change into phosphoglyceric acid. Will change into phosphoglyceric acid. Clearly, I need to add phosphate at the third location, at the third position, third carbon. Do you all agree? Yes? No? Who cares, ma'am? Ladies and gentlemen, if I am changing glycerate to 3-phosphoglyceric acid, I need to use ATP. I was supposed I was supposed not to use ATP here. I'm wasting energy. But yes, the good part is this 3-phosphoglyceric acid will enter the C3 cycle. Okay. Now the problem is, you might ask me, ma'am, in C3 cycle also you used energy. So what if you used energy here? Okay. My problem is that, oh, something is wrong here, yaar. Oh yeah, it is right. Yeah, this additional energy will be used to convert glycerate into phosphoglycerate. And whatever is happening in the Kelvin cycle, that is anyway happening. That is anyway happening. That energy I will use, and I have used this additional energy to convert, to metabolize, because I could not pull up with this compound, with this 2-carbon compound, that is phosphoglycolate. Okay? And that is why this is a wasteful process. Is that very, very clear? This is photorespiration. Now what do I do? How do I adapt to ward off or to take care of photorespiration? You focus on the major culprit, which is Rubisco enzyme. The problem was that Rubisco was combining with oxygen. Yeah? Whenever there were external conditions which were changing, and external conditions cannot be fixed. And even if the temperature is not that high, light intensity is not that high, it's a rainy day, still carboxylase and oxygenase having the same active site sees, like I said, some amount of oxygenation. So I am, as a C3 plant, I am never realizing my 100% potential of carboxylation. It's always a little less, because my oxygenase site, I am distracted all the time. Okay. So then comes what you were asking me, which is C4 cycle. C4 cycle, I feel, is going to give you a lot of questions this year. Ma'am, are you manifesting it? Why not? It is given so nicely in NCERT. Why shouldn't I? Yeah. What do you think? Understood a little bit of photorespiration, everybody? Ma'am, it was tough. Why did you tell us? Why do you go outside? To prove categorically that you guys are not studying at all. Hi Chinnu. Aditya, no, my lecture is not enough if you are studying the chapter for the first time. You should be in a dedicated batch and study the detailed lecture, detailed chapter. This is for people who have studied the chapter in some batch, somewhere, anywhere. I don't recommend one-shots for the first timers. But yeah, you can join the endgame batch. There we will take the detailed lecture. I'm also going to add NCERT decoding to those lectures, because we have classes every day. I think the link is given in the description box. And I hope you know the other teachers also who are teaching along. Do you? Solve this question, everybody. Come on. Namaste. Amusing. You guys are amusing. Yeah. Why do you guys laugh at simplest things? Yeah, I would never understand. Come on. A plant in your garden. Oh, nice. I have a plant in my garden. Avoids. This is NEET 2016. 2020. Why do I have a different question? Okay. The oxygenation activity of Rubisco enzyme in photorespiration leads to the formation. See, you can skip the other steps of the reaction, the organelle reaction, but you cannot skip the what happens in chloroplast. Kindly don't. It's a request. Is it visible now? So see, you always make me aware of the fact that I am coming in the way. Afnan has been good to me. Glycine is an amino acid that has a single hydrogen atom as its side chain. It is the, I lost you, that's the only amount of chemistry I can handle. It is the simplest stable amino acid with the chemical formula NH2CH2COO. Achha, why it is called 2 carbon? Everything is happening. Everything is a 2 carbon. I am focused at metabolizing 2 carbon compounds. That's why. You guys answered it correctly. The 2 molecules of a 3 carbon compound. What is happening here? 1 molecule. Oh, this is wrong. It should be 3. My bad. As if you knew the answer. I feel like what? What? Yeah? Superstars you are. What to do here? The oxygenation activity of Rubisco enzyme in photorespiration leads to the formation. What is happening here? 1 molecule of 3. Oh, okay. Yeah, now I know why I put this question. The intent to put this question. Yeah, I usually don't put it like that. Okay, guys. So see, everybody, if this was the reality, here in class I corrected it, made it 3, and we are happy in our own world. But if in the exam center, you see a question which doesn't have your choice, if this is the reality, then what do? You choose the most correct option. Okay, nobody will hear you there. You can't get hold of the examiner and tell him that, the question is wrong. What do I do? Every year that happens. If NTA is in good mood, it will give you bonus marks. If not, so then you will choose this. Amusing. Cool. Let's go to C4 plants here. मैम नोट्स इसके कहाँ मिलेंगे? Can't stop smiling looking at your messages. Wow. Okay, ladies and gentlemen, let's begin with C4 plants. Now people, in the tropical areas, whenever there is a problem that happens for a long time, some or the other species will take the lead and make the change. It is very difficult for a species to make a change at the biochemical level or the metabolic level. But C4 plants did that. No biochemical change will happen till I change the structure. If you don't change your lifestyle, don't expect that automatically you can sit for 12 hours a day, 18 hours a day, watch some strategy video, watch some mighty teacher telling you, hey, this is the timetable of a topper, this is the plan of a topper, this is what everybody does, this is it. And it will automatically happen just by the theory of it. Okay, so they made structural changes, but this was done by, till now it has been shown by tropical plants. Tropical plants which see the conditions that I mentioned earlier. The question comes from the example of these plants. Maize, one of the favorites, Z maize. Sorghum has seen a question in the past. Sugarcane has seen a question. And the weed amaranthus. Amaranthus. I to love amaranthus ka sabzi also. For me, it's not a weed. So these plants have shown something called as Cran's anatomy. So they made an anatomical change. Cran's anatomy. Now, although these are all monocots, na? Maize, sorghum, sugarcane are all monocots, but don't carry this misconception. It will be seen in dicots also. What is Cran's anatomy? Let's get a hold of that. Cran's means wreath or wreath, however, which simply means the things are happening in a circular manner. So, what happens? What are the three components of Cran's anatomy? Well, it's definitely, I am somehow getting cold every time I take a class. So, the first thing is the mesophyll cells, the parenchyma cells where chloroplasts are present, are present in a circular manner. Mesophyll cells arranged in circular manner around vascular bundles. If you remember the structure of leaf, ladies and gentlemen, forget about leaf. If you remember the structure of monocot stem, you remember bundle sheath cells protecting the vascular bundles, sclerenchymatous rather, toughness. If you have not watched the class of anatomy, explore the playlist on this channel. You have the entire one-shot lecture of anatomy of flowering plants. Do watch that on an increased speed of 1.5x or 1.75x and you will be informed with the organ anatomy. Do you see this? Do you see this? Ma'am, why am I doing this? What is the benefit of this portion of Cran's anatomy, ma'am? Well, think about it. It's common sense. This way, first of all, I am increasing the water availability, which is a challenge in tropical, in high temperature plants. I am reducing the intensity of sunlight. I am reducing the intensity of sunlight. We are holding together. We are decreasing the area. Okay. So this is why they should be present in a circular fashion. What is the second portion of Cran's anatomy which makes it special? Thick-walled. Thick-walled bundle sheath cells. Bundle sheath cells. So now the cells that you studied with me in organ anatomy, they become even more thick-walled. Children, I want to put the culprit in the jail. As simple as that. Rubisco is acting notorious since millions of years. He is like, I like carbon dioxide also, but I like oxygen also. We want him to work only for carbon dioxide. We are not happy with oxygenase activity. So we spatially isolate. Once you understand what I just told you, spatial isolation, this is going to make sense for you. So the first door of my jail is closely packed mesophyll cells. I increase water availability, which lowers down the temperature here. Okay, so these thick walls are serious business here. This thick wall simply means that I am so thick that I am impervious to gaseous exchange. Or in other words, I don't want oxygen. Oxygen will not come in, carbon dioxide will not escape. So I am spatially isolating. Let me show you the bundle sheet cells here. Let me show you. Yeah, these are the bundle sheet cells. Very, very thick. What am I doing, guys? I am spatially isolating Rubisco, because Rubisco is going to be present here. Rubisco is going to be present in bundle sheet cells. I completely arrested him in thick walled bundle sheet cells. If Rubisco is present here, he is doing something. He is not on vacation. Most people work more on vacation than the usual days. But yeah, Rubisco is interacting only with carbon dioxide. So there are two mechanisms which sort of wrap up or tell you the crux of C4 cycle. One is spatially isolate Rubisco, and another one is, Baba, you increase intracellular. Intracellular means within the cell, lock carbon dioxide. This guy gets distracted because of oxygen, na? Don't even show him oxygen. He doesn't even know the existence. You arrest him first. You arrest him by locking him with mesophyll cells. Okay? You have reduced the problem areas, you have reduced the temperature, you have reduced the light intensity. So there is no chance of oxygen carbon dioxide ratio getting disturbed. Secondly, you lock whatever carbon dioxide is produced within the cell. Increase intracellular carbon dioxide concentration. Can we do that? This much is clear or not before we go to the cycle? Cycle is easy. You should know what is happening. Oh, let's solve this question here. Is it based on that? Let's solve this question, everybody. I want the answers in the chat box. This is the last pathway of today. C4 is the last pathway. I mean it. If I am not forgetting anything. I want to PDF. I want to PDF. PDF. I was busy in celebration of Sri Ram Mandir. Okay. Yeah, if only. Any answers? Somebody has answered. इसका PDF कहाँ से मिलेगा? There is no break. Does not exist. Out of stock. Anything else? Oh. Oh, man. You guys are, that's an excuse. Options are not visible. That's such a lame excuse. They were visible. You guys are lying. For everybody? इसका तो PDF नहीं मिलता है और बहुत सारे तीर्थ यात्रा करने के बाद मिलता है. Okay guys, let's read it out together. What is the role of large bundle sheet cells to protect the vascular tissue from high light intensity, to provide the site for photorespiratory pathway? Bundle sheet cells are not protecting from high light intensity. Yeah, be very specific. To increase the number of chloroplasts for the operation of Kelvin's cycle, to enable the plant to tolerate high temperature. Protect the vascular tissue from yeah, this should be the option according to me. That is it. I have got nothing to do with the vascular tissue here, na baba. Yeah, this could go for negative mark. This could be a ranker question. 2022 is the paper. I loved 2022. Rankers question. Nobody scored 360 out of 360 in 2022 onwards. There's one thing that I'm missing here. There's something called as dimorphic chloroplast. Have we written that? We haven't. Let's write it. It's given in NCERT. I think so, not very sure, because what I remember a lot is old NCERT. Here, what do you understand by dimorphic chloroplast? Very simple. Di is 2. Morphic means forms. Morphic means forms. So, what they say that this mesophyll cell is going to take part in a lot of light reaction. Okay, so mesophyll cells have granule chloroplasts, whereas bundle sheet cells have agranule chloroplasts. Now, to me, this is very important as an AR question. Why would I have agranule? Not all chloroplasts are completely, it's never null, it's not zero. Some amount of light reaction will happen, but understand my major enzyme, my RUBP is present in bundle sheath. I am concerned about dark reaction. My life is dedicated to carbon dioxide fixation, as simple as that. Assimilatory power I will get from mesophyll cells. So, this is called as the presence of dimorphic chloroplast. There is division of labor between mesophyll cell and bundle sheath cells. Maize plant thought, you know, I'm done with photorespiration and wastage of energy. Yeah, might as well do division of labor. Anyway, bundle sheath cells are there, yeah. They are protecting the vascular bundles, give them some work. So, now chloroplasts will be there, but they will be rich in photosynthetic enzymes, not pigments so much. Cool? Okay, very good. Now, let's get to the pathway, and this is the last pathway of today's class. Really, it's the last pathway. Of course, then we have the factors affecting photosynthesis, which is a teeny tiny topic, and early experiments always get you 1 or 2 MCQs. We will discuss that also. You can keep your NCRTs ready for experiments. C4 pathway, people, I said that there is the role of 2 cells. This is the mesophyll cell, just like how we did for photorespiration, and I have the BS cells, bundle sheath cells. Of course, bundle sheath cells are quite thick walled. They are going to be thick walled. That is my job, because my walls should not let anything enter me. Yes, of course, there are going to be plasmodesmatal connections between them. That is mandatory. That is mandatory. Now, the beauty of this process lies in double fixation, dual fixation, ladies and gentlemen. The problem is, if atmospheric concentration of carbon dioxide and oxygen is disturbed, my enzyme was going berserk. So I take the role of an enzyme which anyways does not have oxygenation capacity, rather likes carbon dioxide a lot. Okay, and my initial carbon dioxide fixator compound or acceptor compound is not RUBP anymore. It is PEP. PEP is nothing but phosphoenol pyruvate. Phosphoenol pyruvate, or PEP. This cycle was discovered by Hatch and Slack, also called as Hatch and Slack pathway, HSP. Oh, wow, you'll never forget that. Didn't realize. Yeah, HSP pathway. Okay, HSP. C4 cycle is HSP. You'll never forget it now? Okay, ma'am. So this is a 3-carbon compound, ladies and gentlemen. This is a 3-carbon compound. Always, if you want to understand the life, not the life cycle, the biochemical cycle, always go on counting the number of carbons. Now it combines with atmospheric carbon, so I get a 3 and 1 4. I am going to make a 4-carbon compound. Yes, and hence I get the name as C4 pathway. In C3 pathway, the first stable product was a 3-carbon compound, PGA. Oh, so many questions every year. This is such a scoring question. Who's the first stable product? A 4-carbon compound called as, it is a dicarboxylic acid. So this cycle is also called as dicarboxylic acid cycle. Not very famous name, but yeah, you understand. Here the enzyme which C4 plants are very proud to introduce is the peptase enzyme. You see, this is carboxylase. Peptase here has only carboxylase activity, no fear of oxygen getting combined. This is called as the initial fixation or primary, I am writing it in short term, primary carboxylation. Comfortable? Can I say that? Why? Because this cycle has the characteristic dual carboxylation, ladies and gentlemen. That's what makes it special. One of my favorites. I should stop saying that. Okay. Now, this oxaloacetic acid gets converted into either malic acid or aspartic acid. Aspartic acid. Yea or nay? Both are 4-carbon compounds. No problem, ma'am. I've just converted them. Okay. They get transported through the plasmodesmatal connection into bundle sheath cells. Okay. So, what we are going to do, This is your mesophyll. This is what he's interested in. Okay, and bundle sheath here. Bundle sheath. Rubisco is waiting in the bundle sheath cell. Thick walled, thick walled. Now malic acid, malic or aspartic, any one, not both, not both, or aspartic acid will be decarboxylated, ladies and gentlemen. 2, there we go. 2, pyruvic acid. Pyruvic acid. Okay, this is CO2, and this step is called as step A. This is step B. This is called as decarboxylation, or you can call it transport. Both are happening together, na? If this doesn't get transported, it won't proceed. Sequential transport. Okay. Now this carbon dioxide, we are very happy. This will keep happening. This decarboxylation will keep happening. And my intracellular concentration, who's the cell in the question? Bundle sheath cell. My intracellular concentration of CO2 is going to accumulate, is going to increase, and I am going to happily combine with RUBP. I am going to be fixed by RUBP and C3 cycle will proceed. With me? But here the difference is that Rubisco has no clue. It is realizing its 100% potential of being a carboxylase enzyme. Being a carboxylase enzyme. Happy? Works well with you? Now, I have to continue the cycle. So, I transport this pyruvic acid through the plasmodesmatal connection and bring it back to mesophyll. Okay. So, this pyruvic acid has to add the enol group. Is that alcohol group? So, when it gets converted to PP, pyruvic acid, I think double O bond or something, not sure. Pyruvic acid, phosphoenol pyruvate. Phosphoenol pyruvate, I need phosphate group. So, I am going to use, this is very crucial. NCERT says it in theory but doesn't prove it. So, I am going to use ATP here and the rest of the chemistry, and I change it into PP. This PP will continue forming oxaloacetic acid. A happy world, no problem. But my problem is here. Everything seems good, no problem. This step is going to be called as the third step, which is, ladies and gentlemen, regeneration. Regeneration. Regeneration was a step in C3 cycle also. Here also it is a step. Yeah, and this is called as, also remember, prove the dual carboxylation, second degree, or the final secondary or final carboxylation. Okay, ma'am, no problem. 2 carboxylations, no problem. Questions like, who does the secondary carboxylation? Who is the final acceptor? Rubisco. So, C3 cycle is a universal cycle. Okay, ma'am. Now, what happens is, you know what I see in the products? Have a look at the screen. Have a look at the screen at this point of time. Pyruvic acid looks like one molecule of ATP to become phosphoenol pyruvate. But actually in products, I see AMP plus 2 inorganic phosphates. This is my problem. There we go. In order to convert it into energized AMP again, I would require 2 phosphates. This means that I have used not 1 but 2 ATPs here. Very important. I have used 2 ATPs here because on the product side I get 2 inorganic phosphates. Definitely quite a sensible thing that once again I would require 2 phosphates. This increases the overall expenditure of the entire C4 pathway. Let's count it together. Now, ladies and gentlemen, you know it, post break we counted C3 cycle expenditure again. For one cycle, you use 3 ATP, yes or no, and 2 NADPH, yes or no, yes. Now, for one molecule of glucose, okay, let's count for one cycle itself. Now, for one cycle, I am anyway using 3 ATP and 2 NADPH. Now, I will add 2 more ATP. So, 3 and 2, even if you ask me for one cycle, let's say you are saying, ma'am, just tell me what happens to fix one molecule of carbon dioxide. Simple. Let's start from very simple. There we go. I got 1 carbon dioxide from the atmosphere, ma'am. That's it. I'm not worried about the number of cycles. So, even for one molecule of glucose, Baba, which doesn't happen, but okay, for the counting purposes, we have 3 ATP and 2 NADPH. This is definite for your second carboxylation. For your C3 cycle, let's write C3 cycle. And now, in the step of regeneration, even for one molecule of carbon dioxide, add 2 ATP owing to C4 cycle, C4 regeneration. You want to do it this way, you do it this way. Okay. So now, 5 ATP plus 2 NADPH. Oh, okay ma'am, doesn't seem like a lot. I can do with this. But how can you forget? How can you forget that you can't, you are never talking in terms of one cycle. Don't be in a fool's land. We fix 6 carbon dioxide with 6 PEP. Yeah, so into 6, what do you get? 30 ATP plus 12 NADPH. What was the ATP expenditure in C3 cycle? 18 ATP. 6 into 3, 18 ATP, double the amount. What do I do, ma'am? The plant is ready to spend double the amount of ATP. Perhaps because the loss in photorespiration is even more. We don't know. We haven't calculated that. Because it's not only the loss of energy in photorespiration, it is also the loss of precious carbon dioxide. So in totality, plant thought, yeah, this is a good option. Let's go for that. I would spend extra ATP. But plant is not a fool. Plants are even more intelligent than us. Any day I tell you. Because we always get distracted with emotions. Plants don't. they are going to run more cycles of cyclic photophosphorylation. If I am a C4 plant, I don't need extra NADPH. Are you able to relate between the two facts? Beautiful, isn't it? If I am a C4 plant, I don't need extra NADPH. It's the same as C3 plant, but I need double the amount of ATP. Okay, let's give 700 nanometer of light continuously to PS1, more cyclic photophosphorylation, ATP will be formed. Happy. If you thought why cyclic photophosphorylation ever existed, what was the need of a cyclic version? Z scheme was enough. Why? Good. Let's see what's happening in your heads. I think whoa. One sensible text I can't expect from this population. I fear, what if I become like this? I won't become like this. I want to talk mindfully. Clear? Any doubts? Definitely. Even if you say you don't have doubts, I know you have doubts. So, I will have doubt sessions exclusively for this chapter because I understand it's not easy. On the platform, free special class. We'll schedule it. You will see the notification if you follow my profile on Unacademy app. I will have a doubt session separately. I will have a PYQ session separately. Cool? Yes, but NCERT decoding we'll do in endgame batch. It's quite intense for this chapter. Ma'am, break please till 12:30. What? Break till 5th of May 2024. Given. Do whatever you want to. See, this is not the time that I or any teacher or any elder has to tell you, hey, study, it's important, it's good for you, it's going to change your life. If somebody has to tell you around this point also, there's something wrong. Wow, take break and regret after May. What do you think? What should we do now? If you've been solving 200 questions for PGR, for morphology is quite a big chapter. For anatomy, you should solve 500 for photosynthesis. If you want to really irritate and provoke a reaction, there are so many other places to go to. This is the NCERT snip. I think I have not loved C4 cycle given anywhere else than this book. Lovely means lovely. Second time, today I have repeated light reaction 5 times in the class. Who does that here? Come on. Nobody does that. It's easy to wrap up photosynthesis in 3.5–4 hours rather. I hope it benefits you. I've repeated C3 I think twice. C4 also I'll do twice. Thank you, Indu. Not, oh, my mind, my eyes. Okay, boys and girls, C4 pathway, right? The last chance that you have. There is division of labor between mesophyll cell and bundle sheath cell. Ma'am, you said that. Point number 1. They are connected through plasmidesmata. Ma'am, you said that. Point number 2. Ma'am, initial fixation happens in mesophyll cell. Okay, ma'am. Through the compound, 3-carbon compound called phosphoenol pyruvate. Yes, ma'am. PEP. On fixation, ma'am, it gives me a C4 acid. You told us it is oxaloacetic acid. Ma'am, it changes into, you also told us that before getting transported, it changes into malic acid and aspartic acid. NCERT, as she is just writing C4 acid. मैं नहीं बताऊंगी. So oxaloacetic acid changes into malic acid or aspartic acid. Transport happens, but immediately as they enter the bundle sheath cells, the second step also happens. Baba, this is the first step, na? This is the second step, decarboxylation. Yes, no, kind of, sort of, don't know, don't care. Decarboxylation. Okay, so I get mighty carbon dioxide here. Thank God, thank you NCERT for doing this at least. I enter Kelvin cycle, simple. Aligned? Then I change into a C3 acid, you guys know, that is pyruvic acid here. Okay ma'am, if you say so. This pyruvic acid has no job in bundle sheath cell, in BS cells. It goes, gets transported and regenerates into the initial compound. But here there is a problem which is not a problem. Yeah, good. That is NCERT. Question. Why am I so cold? I should get my jacket. Whoa, whoa, whoa. Answers please. Everything other than answers. Oh, sorry. See, this time I know. People, people. Sure. Sure. Ma'am, we can't take out time from our chatting. You only solve the question. The primary carbon dioxide acceptor in C4 plants is PP and found in mesophyll cells. Yes. Mesophyll cells in C4 plants lack. Yes. Thank you very much. Thank you. 22nd question. Answers in the chat box. Guys, you can also join the Endgame Telegram group. I've heard there is no harm in that. NEET 2021, easiest question of today evening. The first stable product of carbon dioxide fixation in sorghum. Sorghum is a known, I told you, right? I've seen a question on sorghum. There it is. 2021 is recent. It is pyruvic acid, no, sorry, oxaloacetic acid. Okay, this is a table given in NCERT. We will also do these tables in Endgame batch. Today the batch has started. I would strongly recommend that you join that batch. Let's do this table together. Come on. Cell type, answers in the chat box. Come on, people, start. The first one. Cell type in which the Kelvin cycle takes place. C3 plants, it is M, B, bow, MB bow. Cell type in which, okay, C4 plants, Kelvin cycle, B. You got to correct me where I am wrong. Actually, you should answer. Cell type in which the initial carboxylation reaction occurs, M. She said nothing through that cycle in the diagram, but this table, everything said and done. How many cell types does the leaf have that fix carbon dioxide? C3, 1. Sole mesophyll cell. Okay, here the choices are 1 and 2. So there is 1 mesophyll, 2 bundle sheath and mesophyll. Somebody is smiling at this. Which is the primary carbon dioxide acceptor? RUBP? RUBP. C4 plants, who's the primary carbon dioxide acceptor? I don't know. Shraddha, stop answering. I said stop answering. Stop. It is PP, right? Number of carbon in the primary carbon dioxide acceptor, kindly, sweetly. Keep my heart alive here. Stop being optimistic. You guys will never answer. Primary number of carbons in primary carbon dioxide acceptor in case of C4 is 3. PP is a 3 carbon compound. Which is the primary carbon dioxide fixation product? PGA, OAA. Hence I get the name C3 and I get the name C4. Ha ha. EG. Number of carbons in the primary carbon. I just said that, right? Acha, when the question comes now, read it carefully. Is he asking acceptor, number of carbons, carbon atom in the acceptor, or he is asking in the product? Sometimes you are like, in the exam center, we go very hurriedly. So here you have 3 and you have 4. Does the plant have rubisco? Most abundant everywhere, present everywhere. Yes and yes. Does the plant have pepcase? No. Yes. Which cells in the plant have rubisco? L. Which cells in the plant have rubisco? Here it will be mesophyll and here it will be bundle sheath. Agreed? On the line? With carbon dioxide fixation, this is nice. Eyes on the screen. Carbon dioxide fixation rate under high light conditions. I've been speaking about it. Yeah. So fixation rate when I increase the light condition, low. I am not bothered. I have adapted myself to not get affected by high light conditions because my mesophyll cells are closely packed and my bundle sheath cells are very thick walled. So it will be high. If you were thinking medium, many people think it's medium. No. Even at 200% of the light intensity, do you know? C4 can function. Whether photorespiration is present at low light intensities, negligible. C3 plant will have negligible photorespiration. He is okay at low light intensity. Here, negligible. Low light intensity is not a problem because temperature is also low, mostly with low light intensity. Whether photorespiration is present at high light intensities? Well, high, negligible. Whether photorespiration would be present at low carbon dioxide concentration? High, and negligible. Why? I have intracellular carbon dioxide concentration in case of C4 plant. I am not dependent much on the atmospheric carbon dioxide concentration. I would work with 0.03% also. Ma'am, please tell me where is secondary tissue. Wow, majja. Whether photorespiration would be present at high carbon dioxide concentration? Negligible, negligible. Photorespiration is the consequence of high oxygen concentration. But then this is a very blanket statement. At carbon dioxide is the most sensitive factor for the plant. We'll speak about that in factors. Temperature optimum. Interesting. Suddenly got a feeling. Shraddha, this question will be asked somehow. I don't know. It's not a very good question, but this will be it. It is 10 to 25 degrees Celsius. According to the text, over the years this has changed, of course. They will not be able, their enzymes will not be able to function beyond 25 degrees Celsius. Here it is it given? It's not given, sorry. Let's choose from the options. This one, 20 to 25 degrees Celsius. Hello. and here it will be above 40. If you were thinking 30 to 40, that's not true, it is above 40. Now she's asking the examples. I already gave you the examples of C4. Kindly turn the pages. Here you include anything, yeah. You include rice, you include wheat. Not maize. Wow. Sorghum, wheat, barley. Homo sapien has joined the class. Ma'am has already taught new families. Sanjana, check the playlist. Okay. It'll be, Sanjana, it will be done in endgame batch also. If you want to study in detail and live. The link to endgame batch is in the description box. If I lost a kilo for every time I said that, I'll be a happy person. Ma'am, please do ecology after plant physiology. Oh, in the entire evening, this is the first sensible message. We can do that. In fact, that is the plan. In class 12th, in your class 12th syllabus, we did reproduction, right? Then you guys are done with almost everything. We'll do ecology now. Don't worry. I'll also speak to Ambika ma'am. Such useful and amazing and wise messages. I'm so... Okay, what is law of limiting factor? Anybody? There was a gentleman called as Blackman. He gave this law. He said, if a physiological process, any metabolic process, is affected by a lot of factors at one point of time, only a single factor will affect the rate of this process. And how do you know it is which factor? It will be the factor present in the minimum range, because everything is present in a range when we talk about metabolic processes. Rephrasing it, how do you know it is which factor? It is the factor which is present in the minimum amount or in the lowest speed, pace, however you want to say it. The classic example that I always give is, usually once your dish is done, sometimes the taste is really enhanced. You make a stir fry, you make a salad, you're eating a pizza, whatever you like. It is the very small amount of seasoning, some oregano, some rosemary, tiny 3-4 drops of perhaps olive oil, yeah, if you like it. Yeah, so that is how this process could enhance the rate of this factor which is in the minimum range. What is the range here? Range is the difference between the maximum and the minimum. Okay, that factor, and it's only one factor. So Blackman conducted a series of experiments. He took the plants and he said, at one point I am going to give ample amount of light. I am going to give ample amount of chlorophyll. I am going to give everything, water also I am giving. But I am not giving carbon dioxide much, little bit maybe. So the one which is present in the scarcity becomes limiting. He said at this point of time, if I want to, some photosynthesis is happening, we are not talking in null. If I want to really see a spike in the rate, then I need to do something with what is not present at this time. Okay, once I have given that factor, let me reduce light, then light becomes the limiting factor. Okay, so how do you write it? If a biochemical process is affected, and for that you need a lot of ingredients for the dish, right? It has to be affected by multiple factors. If a biochemical reaction is affected by multiple factors, it is affected by only one factor at a time, which is required in minimum range or has the slowest pace you make your own definition, that's okay. Cool. Many people disagreed with him, and I also sort of disagree, but till today it has been quite accepted. People said, yeah, what if the chloroplasts which are close to the epidermis are receiving ample amount of sunlight? For them, light is not a limiting factor. Something else could be. Water could be. Water is rarely a limiting factor. Just giving you the example. So, according to the location of the cell and at one given point of time, limiting factors could vary from cell to cell. So, this is not entirely true. Do you know that in a mesophyll cell also, if this is a mesophyll cell, the arrangement of chloroplasts changes. Chloroplasts are quite dynamic, changes according to the intensity of the light. This can be asked as a AR question, and this is given in NCERT. I will be arranged like this, perpendicular to the wall of the chloroplast. If the light intensity is very high, I don't want to get burnt up. So, NCERT has asked it in the form of a question. This is perpendicular arrangement, yeah, 90-degree arrangement. And I will be arranged according to along the tangential walls. You know, right? I have spoken about this in anatomy. These are called as the lateral walls, the side walls. These are called as the tangential walls. When we drew endodermis cell, when we drew organ anatomy, I spoke about this basic thing. What are you talking about, ma'am? How do we know what happened? Okay, so this is the thing. Now let's talk about the factors which affect photosynthesis. Could we? Ready? They would be external and internal. External and internal. Yes, we can do that. What's the time? Ma'am seldom knows time. Oh. Oh, we finished the break around 8:48. No wonder. I've been standing since 3 hours now. So 8:40, 11:40. Do you want a break? I have half an hour more to take. Half an hour maximum. Would you like a break? Let's talk about factors after 15 minutes. Okay, so we'll take half an hour more of class. If your heart sends you back, it's 11:41. Let's meet at 12. Good idea. And it will be a 40-minute session. So see, I've been standing since 8:40, 8:45. It's 9:45. Last I checked, not a robot. Seems like that, not a robot. Cool? I'll see you then. Thank you. this quickly. I said 12, but it's 59. That's okay. Continue. Very easy part of the chapter is remaining. Let's finish it off. And I did not wear the mic. Come on. Okay. Saucy, when were you gone? Yeah, I don't have the power to block. So you learn the art of ignorance when spammers disturb the class. And the art of ignorance is a very important art to be learned. A moment, please. People don't realize, right, your family and friends, that you could be in a live at 12:01. Ready, people? Start. I'm not even reading your okay, where were we? Factors affecting photosynthesis. Well, like any metabolic process, there have to be external factors and internal factors which could impact the process. External factors mean more, affect more. They are more important, okay, because they're transient, they're always changing and plant cannot control them. So the first one is light. Okay, the light. We are going to deal with external factors first. Light means the intensity. Everything about light will affect the intensity of light, the quality of light, and even the duration of the light will affect. Well, intensity of light, if you ask me, certain plants love light and they are called as heliophytes. Heliophytes. Example is Delbergia. Yeah, Delbergia. And certain plants don't like a lot of light and they are called as sciophytes. Sciophytes. Let's write them as shade plants. Sciophytes. Happy? For example, oxalis. Nobody will ask you the examples, but you should know that every plant varies in liking the light intensity. Okay, ma'am. Now, people, there is something called as light compensation point and there is something called as light saturation point. Light saturation point is the point where photosynthesis will experience its highest rate. You see this? at this light intensity, after this I will experience asymptote here. Asymptote or stagnation or a stationary graph. So till here, from here till here, if you increase the light intensity, I am very happy. My rate of photosynthesis will increase. But after this is called as light saturation here. Light saturation. Okay? Which is interestingly 52% light saturation point. Let's write this also. Light saturation point is spoken about for intensity. Happy? I'm speaking of intensity. This point is 50 to 70% of total sunlight in C3 plants. Why? If I increase intensity beyond this, photorespiration, and this is 200% for C4 plants. With me? Now what is light compensation point, like I was speaking about? Light compensation point is the point, I think you've studied that somewhere, where the rate of respiration is equal to rate of photosynthesis. There is no gaseous exchange. Light compensation point is that point in light intensity here. I too like this concept, light compensation point. Light intensity at which there is no gaseous exchange. Otherwise, you're supposed to give me oxygen as a result of photosynthesis. You're supposed to take in carbon dioxide if you're respiring. Here the rate becomes equal, not permanent. The plant cannot be kept in light compensation point. Not possible. Okay. So, light intensity at which there is no gaseous exchange here. No gaseous exchange. Or in other words, rate of respiration is equal to rate of photosynthesis. Okay, makes sense? Should, because it's easy. Talking about this one, duration, not really a major factor. But you can't give me 12 hours of light. If you go to North America, you go to Europe, in summers, the daylight is 12 hours sometimes. In summers, yeah, it is. Whenever I have visited, I have experienced 12 hours. It will burn chlorophyll molecule. Even shield pigments can't help it. That way duration matters. And talking about the quality of light here, quality of light. Okay, quality of light. Then I don't need to tell you anything. Quality simply means what range of wavelength do I want. So I already know, give me blue, give me red. I am happy. But Emerson's effect carries weightage that you need to give a mix of wavelengths. Canada, I said North America. Kindly look at the globe. Yeah, this is a biology class. Okay, next, CO2 curve. CO2 is present in the atmosphere at 0.03%. If you increase till 0.5%, the rate of photosynthesis will increase. This is a very important PYQ. The serious ones, very important and frequently asked PYQ. 0.5% rate will increase, but the moment you touch 0.1%, I am not happy. The rate will decrease. So, people, eyes on the screen, look at the range. If I apply Blackman's law, can I say that carbon dioxide is the major limiting factor? Now, the optimum concentration of carbon dioxide, or any factor for that matter, optimum concentration means at this concentration the rate could reach maxima. Cool. So this optimum concentration, do you see? Have a look at the graph. Have a look at the graph. This is your C3 species. This is your C4 species. So, I need 360 ppm only for C4 plants. For C3 plants, I need 450 ppm. Because my carbon dioxide fixing potential is low. Okay? A C3 plant has low potential. Yes, low potential of carbon dioxide fixation. I'm so sorry. I think I did the opposite here. 12 AM can bring surprises. Now, when I said this sentence that my potential is low, I just realized that in order to experience high rate of photosynthesis or optimum rate of photosynthesis or maxima, I would need more concentration of carbon dioxide because my potential is low. Because all the time my Rubisco enzyme is distracted because of oxygen. My potential fixing capacity is low. So, this is just the opposite. For C3 plant, it is 450 ppm, and for C4 plant, the maxima will be arrived at 360 ppm. And I actually saw the graph and got a sort of a light into the matter, that you look at this C4, it lies. That is why diagrams and graphs are more informative than theory. Okay, so any given day of blackouts and confusions could help you if you have a photogenic memory of the graph. And C4 will have a greater range, because in C4 you see that there is isolation of Rubisco enzyme. Cool. Let's go to the next factor here. Although this carbon dioxide curve is not in NCERT, there are very few chances of it being asked, but I have still informed you to prove how carbon dioxide fixing capacity of C4 plants is greater. Answers in the chat box, 2017 people. Come on, we are just left with experiments and then you are good to go. With reference to factors affecting the rate of photosynthesis, which of the following statements is not correct? We have to find the incorrect statement. There are other factors also which I will be discussing. Wait. Oh, I need to discuss all the factors here before we go to this question. Cool. Then after these two important factors, light and carbon dioxide, we also have water into consideration. It is the rarest limiting factor. Rarest limiting factor. Why? Because how much ever water you give me in the soil, less than 1% is utilized. Plant knows that any day transpiration can ditch me. Let's not be dependent on something that changes every day. So, only 1% of the water is used. Okay. Then, temperature. Well, you know dark reaction is enzymatic. So, high temperature could denature the enzymes and low temperature could keep the enzymes inactive. We have already spoken about it in the table. It is 10 to 25 for C3 plants and 35 to 45 for C4 plants. Can we do that together? And otherwise there is for every 10 degree Celsius increase in temperature, you double the rate of photosynthesis. Doubles the rate of Can we do this much together? Can you remember this much? This is all you need to know. Yeah, there will be other factors also. You can't ignore the presence of minerals, na? What if my soil, what if the plant for a long time, chronically, is not getting any magnesium? My chlorophyll will not be made here. I need to regularly make my chlorophyll A, na? Chlorophyll A, B, nothing will be made. Okay, and what about iron? How will my ETC work ever? So, minerals and elements will also affect. Talking about the internal factors here, let's talk about the internal factors. Internal is all genetic. What is my makeup? Okay, let's talk about internal factors also. Yes? Internal factors. Yeah, common sense. Genetic factors. Genetic factors like what is the shape of the leaf? Is it a broad leaf? Is it a grass leaf which is narrow? If I am a dicot leaf, I am placed like this at axial and abaxial epidermis, I have a better surface area and orientation for sunlight. Yeah, so could be more rate of photosynthesis. If I am a grass, I am aligned parallelly. Yes, so perpendicularly. So it is the orientation and shape of leaves. Okay, ma'am, if you say so. This you can't change. I was born like this. Then What else could be the factor? Think about it. Internal factors which are related to the plant, not the external environment. Think about it. Yeah, with age, as the plant is undergoing senescence, it will slow down. The enzyme activity slows down. Then what is my chlorophyll content? Chlorophyll content. Yeah. How many chloroplasts per millimeter square of the leaf? To some extent that is also genetic, but what if I am not making chlorophyll? Yeah, that will be directly proportional to the rate of photosynthesis. Okay, so these are some of the factors. Next we talk about the experiments. Before that, just have a look at this question. Some people are sleeping on their systems. Yeah, I don't know when I slept last. NEET 2017. Oh, ma'am, move away. Guys, in PGR, you remember we did a concept in PGR last week that there are hormones which cause opening of stomata. Everybody is answering 3. Very good, you guys answered so quickly. With reference to factors, because I showed you the answer perhaps. Light saturation for carbon dioxide fixation occurs at 10% of full sunlight. Increasing atmospheric carbon dioxide concentration up to 0.05% can enhance. This is also true rather. C3 plants respond to higher temperature with enhanced photosynthesis, while C4 plants have a much lower temperature. Oh, this is absolutely wrong. Tomato is a greenhouse crop which can be grown in, yeah. So, you know, this is the thing. If you have a C3 plant which is troubled, every day, you know, I try to photosynthesize, photorespiration is troubling my life. What do? Keep it in a greenhouse, because greenhouse is going to keep carbon dioxide trapped. That is the greenhouse effect. Huh? Yes? Agreed? Okay. So, this is one of the things that is employed all over in horticulture. You keep a normal C4 plants are sorted, but they are very few in number. Na? So, to increase the yield of the crops at a mass level, build greenhouses. Almost every botanical garden has a greenhouse these days. Hormones. There was a question in the last session that which hormone will cause opening of stomata? That will be, any guesses? Google is always there. Shraddha, why do you want me to lose all the patience and perhaps Yeah, YouTube has a video, listen to this girl, wherein I have visited Lal Bagh and shown the glass house there. You will find that video on YouTube. Yeah. Gosh, not even talking. Okay, so boys and girls, cytokinins cause opening of stomata. More gaseous exchange could increase photosynthesis. Gibberellic acid increases rate of photosynthesis. Abscisic acid, if you are thinking, will decrease the rate of photosynthesis. Now we talk about early experiments, everybody. The first experiment that is mentioned in your NCERT, wherein he has said that if you are, I don't want a red colored plant, thank you. If you have a plant, if you have a nice looking plant, kindly do an experiment wherein you have a test tube, and this test tube has a cotton soaked in potassium hydroxide. I don't know if you've done it in the school, We used to do variegated leaf experiment. That is very easy. You do the starch, iodine test, all of that to tell you that light is necessary. But these are accounted experiments done by scientists, and these scientists have to be credited. Everything happened in a sequence here. In the early evening, I specifically did not write the balanced equation of photosynthesis because I said we don't deserve to write or know the equation, because these scientists step by step came to the balanced equation of photosynthesis which we know today. Okay, it took years and years of work. As microscopes developed, tools developed, stains developed, whatever, radioisotopes, non-radioactive isotopes, heavier isotopes, a lot of techniques were involved, lots of people were involved. Okay, so this experiment is the first one. I think it's 134 page number or something, first half, beginning of the page, right hand side, first half. This is called as Moll's half-leaf experiment here. Moll's half-leaf experiment. Most of the school's curriculums have this. I remember doing it. Okay, Moll's half-leaf experiment. Since I was just in school, I'm sure it is still getting done. Well, you dip half of the leaf in potassium hydroxide. Potassium hydroxide is going to soak up all the carbon dioxide present in the test tube. And you give the light, you let the photosynthesis happen. But you are not giving the carbon dioxide. So on doing the iodine starch test, you know, NCERT at the end of the paragraph writes a question. How will you test whether the leaf has made carbohydrate? मैं नहीं बताऊंगी. So on doing the iodine starch test, this part of the leaf here will turn blue, and this part of the leaf will test negative for starch. Proves, the first proof that I need carbon dioxide. Boys and girls, till now you have this basic equation. 6CO2, 6H2O, light, chlorophyll, and C6H12O6 plus 6O2. This is what I have till now. This part I have proven here. Okay. So once we know this, we go to this second one, that is Priestley. Priestley was a chemist. Even Kelvin was a chemist, I think. Melvin Kelvin. Priestley was a chemist. He did the famous bell jar experiment in 1770. Nobody will ask you the year. It's okay. So he said, you know what, there is something that we release into the atmosphere which is called phlogiston or foul substance, foul air. Phlogiston, if I am recollecting it correctly, okay, owing to his bell jar experiment. Bell jar. There we go. Yeah. He took 4 apparatus. There were four bell jars. In one, he kept a mouse and a burning candle. And after a while, both of them, it's like you getting stuck in a lift for some time. Like I said, extinguished. So combustion is not happening, respiration is not happening. Both are different. You know it. When I kept Mentha everis or the mint plant, well, both of them survived. So he said, these both processes, because he was a chemist, are releasing something, I'm not able to get it, that this plant removes. He called that substance dephlogiston. Foul air which is produced by us, it is removed by something called as dephlogiston. It's not magic. It's not magic, but there is something produced, dephlogiston. Okay, and he quoted something like that. No, this is not the one. I don't know if I have the, but your NCR, yeah, there it goes. One of my, one of the good lines. But when he placed a mint plant in the same bell jar, he found that plants restore to the air whatever breathing animals and burning candles remove. In 1774, later on, in a very short period of time, in terms of discoveries, this is a very short span of time, he discovered oxygen. Beautiful, no problem at all. So Priestley is credited with discovering oxygen. Now boys and girls, this lie is important for us because we are solving this puzzle. You got this, but the problem is, I don't know if this oxygen is coming from carbon dioxide or it is coming from water. For the longest time, up until 19th century, they thought, mid-19th century, they thought that this oxygen is coming from carbon dioxide. Okay, let's go. Let's see what happens after Priestley. Came Wonsasch. Wonsasch was a very nice guy. I don't think so. After Priestley, I think Ingenhousz experiment. Yes, this happened in a sequence here. So sequence is important. Ingenhousz worked on aquatic plants. Well, he kept the plants, green plants, aquatic plants like hydrilla, in dark and light. And he said, I am getting some bubbles. That means some air is produced only in light. So he did not name the bubbles because till then, this is the period 1730 to 1799. So he must have done it before the discovery, Priestley's discovery. He said, you know what, whatever is happening, this reaction that the world is talking about needs light. Because if I keep it in the dark, it's not happening. And I think the last line in NCERT, as is visible, he also spoke about the importance of green parts of the plant. He said, if I keep non-green parts, not happening. Let's read it out. Although NCERT decoding, I said it number of times, will be done in the endgame batch. There you go. Aquatic plant, point number 1, I want you to remember, this is the inference. Always remember the inference of the experiment. Okay, small bubbles were formed around the green parts. There you go. But the major inference that we take out of Ingenhousz's setup is solving this part of the equation here. This one. Okay, so this done. Let's go further. We got to go further. Wonsasch, very nice guy. He gave us something that we are using extensively today. What is that? (1854). We will not ask the year. Okay. Wonsasch experiment was based on, he led us to discover chloroplast. He said, you know what, this green pigment, first of all I tell you that glucose is being formed. He said, people, sugars are getting formed here. And he said this is the first visible product. I really like this inference. First visible product of photosynthesis here. Because oxygen is not visible. Oxygen is not visible. Okay. Later on he said, first inference, major inference is this. So you got the product side of the equation beautifully. He said this green pigment is present in chamber-like cells. He did not tell us that these are chloroplasts, but he said, there are special units. Today we there are special entities, organelles in the cell. He must not have used the term organelle, because around this time, if you remember, microscopes were getting developed. There was no way we could reach up to studying the structure of chlorophyll. Okay, so the major inference, if he'll ask, this is the major inference if the examiner tries to trap you. Underline. Okay, glucose is usually stored as starch. Thank you. His later studies showed that green substance in plant, today we know it as chlorophyll, is located in special bodies later called chloroplast. He found that the green parts in plants is where glucose is made and glucose is stored as starch. Okay, ma'am. As you say. After von Sasch came one of the most remarkable discoveries. This is Engelmann's experiment. I spoke about it. In the evening. Didn't we write that Emerson gave the first action spectrum? If people who were there in the evening class. Well, my mistake, it was Engelmann who gave the first action spectrum. And this spoke about the quality of light that you need. Quality of light that you need. You should go and correct it there, since you are writing extensively everything. Yeah, so he took a plain prism. He would have taken a prism to separate the light, and he got the visible spectrum, yeah, that spread into the various wavelengths, as you know. Okay, and on the other side he could have got a nice filamentous green algae with the name Cladophora. This is given in NCERT. We'll read it together if we have this name. But the smart thing that he did was, he grew it in a suspension of bacteria. Which bacteria? Which are oxygen loving aerobic bacteria. Okay, Cladophora in a suspension of bacteria. Okay, and he saw that somehow this bacteria accumulated after a while of illumination and giving light. They accumulated the most in this region. Accumulation, and in the blue region. So from evening we know that these are the most effective regions of Vibgyor. So Engelmann gave the first action spectrum which we studied for chlorophyll in evening. The least accumulation, little bit of accumulation happened in other regions also. Little bit will happen in your region, like I told you, in the evening. Yeah, in violet and indigo also will happen. This is the area of least accumulation. That is how we devise the PAR. Everybody is happy? No, ma'am, what are you talking about? Who is happy to study at 12 AM? They say that the most turning point in the discovery was Van Niel's experiment. You know why? See, we have discovered everything in the equation of photosynthesis, because he helped us to arrive at the modern or the correct equation of photosynthesis. He was the guy, because he experimented, he took this chance of experimenting on organisms who would not use water on the reactant side. Okay, because this was such a puzzle. Is oxygen coming from carbon dioxide? If it is coming from carbon dioxide, then what is water doing on the reactant side? Or is it coming from the water? Such a confusion. So Van Niel's experiment solved it for us. He worked on purple and green sulfur bacteria. These bacteria, when illuminated, okay, they had CO2, but they had hydrogen sulfide. So these guys, with their own photosynthetic pigments, let it be bacteriochlorophyll, bacteriophyophytin, formed the glucose. But what they made was this and no, this should be 12. I am not balancing it properly. This. No, I am so sorry. 12S is formed. That's it, that's it. That's what I form. So they form sulfur. They form sulfur. Or it could be 6H2S. This could be 6H2S. I wouldn't know the chemistry of it. This looks balanced, right? This looks balanced. But then the oxygen is not balanced. What do you think should be the equation, guys? I think I was right. Into I'm stuck with the balancing the equation, although it's not a part of botany. This is balanced. 12 and 12, 24 हो गया. सख्त 6 कार्बन हो गया. 6 दूनी 12, 6 दूनी 12. Got it? So he said, guys, if carbon dioxide, guys, was the donor of oxygen, then why didn't I get oxygen in this case? Point number 1. Then he said, hello people, clearly hydrogen sulfide is getting oxidized or losing hydrogen and giving me sulfur, and I am getting water, and years after me, like how I am balancing the equation, somebody will stand at 1 AM, what is the time? 1:45, and will realize that the accepted equation or the modern equation where we categorically know that hydrogen is the oxidizable compound. He said exactly that put some compound which is ready to be oxidized. This is what is needed in photosynthesis. Oxidizable compound. Oxidizable compound. The same compound, boys and girls, will give you the byproduct of oxygen also if you want. Here he is getting, hydrogen sulfide is getting oxidized, and these hydrogen will reduce the mighty carbon dioxide. Carbon dioxide is not doing anything. She is just ready to be reduced. He's the doer. He made the call. To people who were sitting on equation of photosynthesis and dreaming that maybe this foul air is giving us the nice air. We breathe out carbon dioxide, that is only getting converted and giving us oxygen. Water is very important. Okay. Now this was what I really like is, later on this equation was kind of thought of, but it was definitely in the books on the stamp paper after Rubin and Kamen's experiment, which they did with heavier isotope of oxygen. So let's understand this also, and then we will finally do the ritual of today. Usually the equation of photosynthesis is written in the beginning of the lecture, but I have waited patiently. Now we deserve to write the balance, and we'll finish the session at the final equation of photosynthesis. Okay. So Rubin and Kamen, what they did, by now they knew how photosynthesis is working. What all I need carbon dioxide, water also they knew. I need water also, I need chlorophyll, everything setup is fine, but this time the water contained heavier isotope of oxygen, that is O18, not O16. This is a non-radioactive isotope. Okay, and they also incorporated this isotope in carbon dioxide. But when they incorporated in carbon dioxide, the oxygen that came here, you see, if I incorporated in water, my resultant oxygen is isotopic. This one is isotopic. Okay, let's not write the equation. We are not balancing. We are just seeing the qualitative. But when they incorporated the same isotope in carbon dioxide, yes, then I don't get the isotopic oxygen. Okay, I don't get it because this oxygen is 16, the non-heavy isotope. Then I am getting O16. Haha. And after this, the world was so happy, because we finally, and the curtains are going to be down on equation of photosynthesis. What do you think? What do you say? Let's do that. So today we know. I don't know what's happening in the La La Land. Correct, ma'am, correct. So happy for your dedication, ma'am. Yeah, said my back and my legs. That's what they said. I like to balance equations on my own. That used to be my favorite chapter in chemistry. I don't know which part of chemistry it is. Organic, inorganic, whatever. So that's why I didn't really ask you guys, wanted to solve it. It was an easy one. What do you know? You guys are Final equation before the curtains are down. Everybody. With my favorite color. So now we know that we need 6 molecules of carbon dioxide, enough. 12 molecules of water, enough. And I need light. I need chlorophyll. Of course, I need enzymes in working condition. In working condition, let's write them since the final honors. And I get mighty C6H12O6, the glucose. And I get 6O2 as the major byproduct. And water gets regenerated. But you know that this is happening in a multi-step process, which you have studied the entire, I don't know how many hours, multi-step process. Ladies and gentlemen, let's see the balancing act. 6 carbon atoms. 6 carbon atoms. No fuss. Do you see any fuss? No. 6 into 2, 12 oxygen of CO2. 12 oxygen of CO2. So what have you learned from Van Niel and Rubin and Kamen? At least not here. At least not here. Okay. So this one, I get 6 here. Okay. How do I have 12, right? And I go and give 6 here. Doable. Now let's count the hydrogen. 24 hydrogen. 24 hydrogen. Okay. There we go. There we go. 12 are incorporated into glucose molecule. And 12 into water. Now let's talk about this oxygen we promised here. That's what they worked on. That oxygen or water will go there. Okay. So this is the aha moment. Ladies and gents, that's how you do photosynthesis like never before. That's it. That's the performance. So what we are going to do is we'll see मॉक टेस्ट में 710 आ रहे हैं, एग्जाम में कितने बनेंगे? 750, 600. Okay, now we will do questions. Let me see if I have questions. I really don't remember if I put questions on experiments. Let me see. Hopefully I do have. Yeah, let's solve this question. And then at least you can say good night. Answer in the chat box. Come on. Don't make me smile here. Come on. We have 6 minutes to 1. Let's finish the class at exactly 1. Hopefully the session will also end when I stop teaching. Somebody is awake to end the stream. Okay, I'll move here. Everybody. Sure. Sure. Okay. One scientist cultured cladophora. As soon as you see cladophora, you should know it is our Engelmann darling. Cladophora. In a suspension of azotobacter, aerobic bacteria, and illuminated the culture by splitting light through a prism. He observed that bacteria accumulated mainly in the region of, what a question, which year? 19. Ma'am, we wish you can manifest right now. The world is sleeping. Wish for it. Ma'am, this easy question should be a part of my paper. Next question. Let's see, next question. What do we have? Carbon dioxide is necessary for photosynthesis. Yeah. What do you think? कुछ नहीं हो सकता यार. अरे बाप. Carbon dioxide is necessary for photosynthesis. The chemical used to remove this gas most effectively from entering a control apparatus is KOH. If you have somebody else, I mean some other compound, I'm sure there is whole concept to this also. Okay? Next, I think we don't have a next. Oh God, I was wishing. Oh, it is AIPMT 2010. Last question of the day, I'm pretty sure. I can't put more than 3. Guys, I would patiently but excitedly wait for your comments on this chapter, because this was photosynthesis chewed and dusted and like never before. So after the class, I want bombarding of comments. Done? 2010 used to be a challenging year for AIPMT, used to be difficult. Let's see. Read the following 4 statements ABCD and select the right option. Underline what the examiner is asking, having both correct statements. Wow. He's asking for a correct pair. Z scheme of light reaction takes place in the presence of PS1 only. So wrong, yaar. Otherwise, how will I make the Z? Only PS1 functional in, yes. Cyclic photophosphorylation results in the synthesis of ATP and cyclic photophosphorylation is only ATP. Stroma lamellae lack PS2 as well as NADP. Correct. So I get B and D. Thank you. And that, what is the time? 2 minutes to 1. So what's up, people? Good morning. How do you do? Let's do another chapter starting from now. If I could just hang upside down and the weight of my body could be on my head, because legs cannot take it anymore. I've been standing since 5 p.m. So we could do another chapter. How about you? You guys are so bad. Let's do another chapter. You're not impressing me by saying that. Yeah, maybe one day, maybe. if there was a pill, there was a medicine. There are actually. Maybe I'm not aware. They say that people are taking some concoctions not to ever get tired. Who knows? UP board se ho. Kaisa hai UP board? Peter, you can study here also. Everything is done in. Just had a cramp in my foot. Yeah. So guys, after the session, after the stream ends, I would wait before sleeping. I would wait for your valuable comments. If you have any doubts, I would hold a doubt class on the platform, that is on the Unacademy app. To get notified for the same, you should follow my profile on Unacademy app. And check the description box of this session. Let me check. You will definitely get the important links. One of them being oh, there is endgame batch link, and then there is Telegram group also. Namaste. Okay people, so we'll meet tomorrow in the endgame class. I don't know if it's 6 or 8 p.m. Some p.m. is there. We'll do, what are we doing in endgame? Morphology. So we'll do morphology. Thank you very much. Take care of your health, wealth, which is your thoughts, and keep smiling no matter what. I'll see you when I see you. Bye-bye.